All right. Welcome, everybody, to Standing for Truth. My name is Donny Budinsky, and I am your host for this evening's important program. On Standing for Truth, we uphold the truth of biblical creation. We also host some awesome guests here with us to help us on our journey and with our mission to provide you with the best and most up-to-date evidence available for the Christian faith. It is a privilege to have Dr. John Baumgardner, a hero of biblical creation, to assist me in this important mission. Dr. Baumgardner will be presenting on the incredible evidence for the global Genesis flood in a valuable talk titled, "The Genesis Flood Happened, Here's How." This program includes an in-depth explanation of the physical processes of the flood, and I can't wait to get into it. Dr. Baumgardner, thank you so much for all you've done to defend the truth of biblical creation. Brother, I appreciate the time that you've offered for tonight's program. And so how are you doing tonight?
Doing very well, thank you. It's a delight to be on your show tonight.
Well, it's a privilege to have you, John. I've been blessed by your work and your efforts in defending the truth of biblical creation for years now. And so what I want to do is give you a formal introduction before we get into your comprehensive presentation tonight for anybody who might be unfamiliar with who you are. And so John earned a doctorate in geophysics for the express purpose of addressing the tectonics issues of the Genesis flood at a professional level. For his PhD thesis, he developed a 3D mantle dynamics program known as Terra. As research scientist for 20 years at Los Alamos National Laboratory, he used computer modeling to explore and develop the concept of catastrophic plate tectonics as a primary mechanism behind the flood. Also, while at Los Alamos, John assisted the German Weather Service in applying modeling techniques used with Terra to the task of developing their next generation global weather forecast model. This model, named GME, became the German operational global forecast model in 2000 and is currently used in more than 20 countries. John further applied his expertise in numerical methods in the development of Mendel's Accountant, a population genetics program, which I am incredibly thankful for, John. That's awesome. For modeling mutation and selection. Current research includes the refinement of Terra to accommodate much stronger variations in rock strength and thereby achieve greater fidelity in modeling the runaway aspects of the flood cataclysm. In other words, John, you're more than qualified to be speaking on tonight's important topic. For anybody in the live audience just joining us, again, what we are focused on today is the reality of the global Genesis flood. The Genesis flood happened. Here's how. For those who want to see more from Dr. Baumgardner, please check the description box of this video where I have the relevant links to his websites. And so, John, let's get right into it. I'm excited for this program. And so I can put up the slides here. And brother, the floor is yours.
Thank you very much, Donnie. For many people today, their mental concept of the flood hasn't advanced that much since they were 4 years old and learned the words in Sunday school that the rains came down and the floods came up. I'm hoping to go in a little beyond that tonight. For more precision, it's helpful to take a glimpse at the biblical text, of course. In chapter 6 of Genesis, we have the words, "Then the Lord saw that the wickedness of mankind was great on the earth, and that every intent of the thoughts of their hearts was only evil continually. So the Lord was sorry that he had made mankind on the earth, and he was grieved in his heart. Then the Lord said, I will wipe out mankind, whom I have created from the face of the land, mankind and animals as well, and crawling things and the birds of the sky, for I'm sorry that I have made them. So it's a picture, a very grim picture of how after Adam and Eve sinned and their very first son murdered the second son, how this wickedness rapidly spread throughout the whole human race. And it was God's only option was to wipe out that generation and start over. Verse 8, though it says, but Noah found favor in the eyes of the Lord. King James uses the word grace there for favor. It's the very first occurrence of the word grace in the Bible. Let's continue. Verse 11, now the earth was corrupt in the sight of God, and the earth was filled with violence. Verse 12, and God looked on the earth, and behold, it was corrupt, for mankind had corrupted his way upon the earth. Then God said to Noah, the end of all flesh has come before me, for the earth is filled with violence because of them, the human race. And behold, I'm about to destroy them with the earth. And then if we jump to the next chapter, in verse 11, it says, in the 600th year of Noah's life, in the second month, on the 17th day of the month, on the same day, all the fountains of the great deep burst open, and the floodgates of the sky were opened, and the rain fell upon the earth for 40 days and 40 nights. So here is an abrupt onset of this global cataclysm. And jump to verse 19, and the water prevailed more and more upon the earth, so that all the high mountains everywhere under the heavens were covered. Verse 21, and all flesh that moved on the earth perished, birds and cattle and beasts and every swarming thing that swarms upon the earth, and all mankind. Verse 23, thus he blotted out every living thing that was on the face of the land, from man to animals to creeping things and to birds of the sky, and they were blotted out from the earth, and only Noah was left together with those who were with him in the ark. And the final verse in that chapter, and the water prevailed upon the earth 150 days. So from a human perspective, what would that have been like? Well, for billions of people, it would have been the end of the world, an end of the world cataclysm for the entire human race, apart from the 8 people on board the ark. A total destruction of all land-dwelling, air-breathing life over the entire earth, as the Genesis text describes, surely must have left behind an abundance of physical evidence. Actually, I might say that evidence is beyond what the human mind can possibly imagine. Abundant evidence today. But just what sort of evidence? What might we expect? Well, for starters, how about billions of dead things buried in rock layers laid down by water all over the earth? I'm repeating Ken Ham here as he describes the flood, what the almost certain result of it would have been. Here we see some photos of fossils, very well preserved, almost in pristine condition, evidence that they were suddenly and completely buried, overwhelmed in sediment and preserved as these fossils show here. What about the rock layers themselves? What sort of physical features ought they display if such a global scale cataclysm had actually occurred? That answer might not be so obvious, but the evidence for global cataclysm is just as clear and abundant with these rock layers as is the testimony from the fossils. All right. This layer cake pattern of sediment layers as exposed in the Grand Canyon is representative of the strata that blanket most of the continental portions of the earth. These layers document document this cataclysm in a powerful and undeniable way. So we see this layer cake pattern of water deposited sediments extending in both directions as far as the eye can see here in the Grand Canyon. And this is typical, this is representative of what's under our feet under most of the continental surface of the Earth. Now, in what way does this give evidence for the flood? Well, first of all, these layers themselves consist of sediment particles of sand, silt, clay, and carbonate that have been suspended, transported, and deposited by rapidly moving water. So these, this immense amount of sediment in this layer cake pattern is composed of these fine particles, sediment particles that indisputably had been suspended, transported, and deposited by rapidly moving water. So that's one important observation. In addition, these rock layers commonly continue horizontally for hundreds to thousands of miles in both directions. This implies that the water processes responsible were enormous in physical scale, operating not just on a local scale, but a global scale. And in addition, there is a global scale discontinuity at the bottom of these sediment layers, of these fossil-bearing sediment layers, and known as the Great Unconformity, discontinuity. And above it, the sediment layers have fossils, and below it there are no fossils. The abrupt appearance of fossils at this physical discontinuity in the rock record is commonly known as the Cambrian explosion. It represents the abrupt onset of the flood and the immediate deposition of a wide assortment of different kinds of animals. Furthermore, this vertical sequence commonly displays flat boundaries between the layers with little or no erosional channeling across the layer boundaries, which is very much different from what we see at the Earth's surface today. And this sharp boundary, this pattern of sharp boundaries is illustrated very nicely with the boundary between the Coconino Sandstone and the Hermit Shale in the Grand Canyon. Here's a photo that I took of that boundary. It's just below the Visitor Center on the south rim of the Grand Canyon. And that boundary is between the Coconino, the lighter colored Coconino Sandstone above, and the reddish Hermit Shale beneath. And this is typical of the contacts between successive layers in this sequence of sediment layers that blanket the Earth. The implications of these observational realities are profound. To deposit such uniform, horizontally extensive layers with flat boundaries between them requires that, first, vast portions of the continental surface were flooded by rapidly moving water and were nearly smooth. The fact that these layers are flat indicates that the surface was smooth. The water speed had to be high to keep the sediment particles in suspension over such great distances. These observations imply a regime of erosion, transport, and deposition in the past radically different from today. Today, higher portions of the continental surface are deeply sculpted by erosional channels. This branching structure of streams is characteristic of the surface today. Sedimentation is generally severely restricted in lateral extent, generally just a narrow band associated with a stream, and then in the delta. Moreover, in most settings today, layering is entirely destroyed by burrowing organisms. So the nice, neat layer cake pattern is not being produced today. What layering may happen immediately after deposition, say in the case of a big storm, is rapidly destroyed by these burrowing organisms. Now, if we look at the surface today, we see that it's dissected by canyons in the southwest U.S. by like Bryce Canyon, Zion Canyon, and Grand Canyon. And these illustrate the dramatic erosional channeling that slices into the modern continental surface. Such features are almost entirely absent in this deeper record. They've been cut after that record was already formed. Moreover, there's abundant physical evidence within the layers themselves that water velocities responsible for their deposition were extreme. In several cases, water velocities were sufficient to produce underwater sand dunes 50 to 100 feet in height. And one good example of this is the Navajo sandstone, which displays giant crossbeds, are called, which are a certain indicator of high-speed water flow. The Navajo sandstone is the formation out of which Zion Canyon has been cut. Here are some giant crossbeds, a little closer view in the Navajo sandstone in Zion National Park. The finer structure represents layers deposited on the front sides of huge underwater sand dunes that were generated by this high-speed water flow. Now, because fossilization requires rapid and complete burial, fossils are a reliable indicator of catastrophic conditions, including that high-speed water flow. So here we have in pretty obvious display evidence, a reliable indicator of catastrophic conditions. Generally speaking, whenever you find a fossil, you can be certain that it was deposited under catastrophic conditions, because the animal, to make a fossil, has to be buried quickly and completely to exclude predators, scavengers, and microorganisms that otherwise would destroy the organism very quickly. So are the processes responsible for these striking features prevalent today? The answer obviously is no. Now, a central premise of Charles Lyell's book, The Principles of Geology, that book was used to train almost all the geologists in the world back in the 1800s. And its central premise was that the present is the key to the past. From what we see in the sediment record, that simply is not the case. The observations contradict that premise, and therefore that premise is simply not valid. The evidences we have just examined reveal that the geology community, ever since around 1830, when that book was published, has been wandering in the weeds for the past 190 years. And it's still there. It still is in a state of confusion because it simply cannot acknowledge that these obvious features of the record are indicating catastrophism. Now, the only place within the biblical account of world history that formation of such laterally extensive fossil-bearing sediment layers could possibly have occurred, of course, is during the Genesis flood. There's no other place in the history of the world, according to the Bible, when such a dramatic physical change could have occurred. Now, as to the intensity of that change, the Genesis text reveals that all this cataclysmic activity unfolded within the time frame of that single year of the flood. The biblical text indicates the flood ended 171 days after Noah got on the ark. That was when Noah and the animals and Noah's family got off the ark. So just very close to a single year. And given this biblical time scale, and the striking physical evidence for a global flood cataclysm, some obvious issues come to mind. First, at a very basic level, how could so much physical geological change occur in such a brief span of time? That's a pretty obvious question. And second, more specifically, what could have been the primary causal mechanism behind this cataclysm? Major answers relating to these crucial questions have come, surprisingly, not from the continent surface, but from the ocean bottom. A huge discovery of the 1960s was that all of today's basaltic ocean crust had been formed recently in Earth history. All of it turns out, is younger than most of the continental fossil-bearing sediment record. So again, let me just repeat that. In the 60s, it was discovered that all of this ocean floor shown here, and we're just showing mostly the Atlantic Ocean floor, but that's true of the Pacific and Indian Oceans as well. All of that igneous rock that covers especially the area adjacent to the mid-ocean ridge system is made out of basalt, and all that basalt has cooled and crystallized since much of the fossil-bearing sediment record on the continent was formed, was deposited. And so this, in terms of this photo I've been showing of the sediment record, all of that record above where that base of the blue arrow is was formed. Well, I'll put it this way: all of the record below that arrow was formed before any of today's ocean floor was erupted and crystallized. So that what that means is that all of today's ocean crust has formed since the beginning of the flood, since the onset of the flood. And this implies that the opening of the entire Atlantic Ocean occurred during the flood, and that continents migrated by thousands of miles in only a few months' time during the flood. So this is providing a much different picture than most people have had as to what happened in the flood. It reveals that there was a lot of large-scale tectonic change that accompanied the flood. And someone might ask, well, what about the pre-flood ocean floor? Well, it's entirely missing from the Earth's surface today. And taking cues from today's ocean floor, where we see seafloor spreading and subduction of old ocean floor, logically it must have been the pre-flood ocean floor must have been recycled into the Earth's interior during the flood. And these observations imply that the Genesis flood, in addition to being a hydrological cataclysm, was also a global tectonic cataclysm. This understanding that rapid large-scale tectonic change was a fundamental aspect of the Genesis flood has come to be referred to as catastrophic, catastrophic plate tectonics. And this concept was first presented at the first International Conference on Creationism in Pittsburgh in 1986. So this idea has been around for almost just under 40 years now. Now, such large-scale tectonic change at the Earth's surface requires that the Earth's interior also had to have been involved in a profound way. So let's review some of the basic aspects of the Earth's internal structure. This is a cross-section of the Earth, a slice through the Earth, and it shows there are two main parts of the Earth's interior. An outer part called the mantle, here with light shown in the medium blue color, which is mostly solid silicate rock. So that's the mantle. And then inside the mantle is the core, which is mostly molten iron. The outer core is molten. There's a small inner core that's solid. The uppermost part of the mantle is the thin, cold, mechanically strong lithosphere that's shown in white here and marked with the arrow. And that lithosphere is broken into about a dozen large plates because they're cold and rock is strong, they behave basically as rigid units, rigid blocks on the Earth's surface. Just below the lithosphere is the 1,000-fold weaker asthenosphere. It's about 1,000 times weaker in strength than the overlying lithosphere. And that weakness allows the plates to slide freely over the region beneath, over the rest of the mantle. Now, at the top, in the center, you see a jagged line, which represents the mid-Atlantic ridge. And that's where the plates are pulling apart, spreading apart. You see the arrows there in the lithosphere showing that divergence. And then at about 10 o'clock, if you look at a face of a clock, you see the Pacific Ocean floor is plunging back into the earth against the coast of South America. That process is known as subduction, where a surface plate, an ocean plate, is able, because of its cold temperature and higher density, to peel off and sink into the interior of the earth, into the mantle. So this way, the surface area of the earth is conserved. You have new ocean floor formed at a spreading ridge, like the mid-Atlantic ridge, and the extra area of crust is compensated for by subduction of cold ocean floor into the Earth's interior, shown here beneath South America. Sorry about that.
Call from Kashi, lovely.
Excuse me.
Call from Kashi, lovely.
So here I want to try to give a little more detail on subduction, and that's how these oceanic plates are recycled into the mantle. Here you see shown as the word trench, pointing to this feature, and that's where this oceanic plate, piece of lithosphere, is plunging down into the Earth's interior, and it's adjacent to a continental region, and you can see marked there continental crust, which is granitic in composition, and often you have that granitic composition. That rock has a lower density than mantle rock and ocean lithosphere rock. So it basically is unsubductible. It's buoyant and unsubductible. So it stays at the surface, and it's the ocean plate that plunges back into the Earth's interior. And as I indicate here, it's the lower temperature of this ocean lithosphere makes it denser than the asthenosphere below it. Even though they're chemically almost very, very similar, it's because the lower temperature of the lithosphere that it's denser and has a natural tendency to want to sink. Now, most of the time where there's subduction, these two plates are locked together. There's a fault between them, but the plates in effect are welded together and are locked together. So it's the ocean lithosphere that's continuing on a continuous basis is sinking, and it's deforming the overriding plate and causing stress to build up on the fault between them. And eventually the stress gets high enough for that fault to break and for slip to take place. And when that slip happens, earthquakes occur. And in addition, when this ocean plate gets deep enough, the pressure forces the water that it has carried down in the surface, so its surface layer, to come out of the rock and rise. And the water lowers the melting point of the rock above it. And this results in commonly of melting at that point. And that melted rock has a basaltic composition and rises and produces volcanoes adjacent to where the subduction is taking place. And this produces a ring of volcanoes around the Pacific Ocean. That ring of volcanoes is known as the Pacific Ring of Fire. So here, this gives you a little more detail on how on the subduction process, and that it's associated with earthquakes and volcanoes. And sort of the companion process is seafloor spreading, and corresponds to what's taking place along the mid-Atlantic ridge. It takes place along a mid-ocean ridge. And the spreading is typically broken up into these short segments that are frequently offset from one another along what are called transform faults. And as the plates pull apart, there is a partial melting beneath them, and that magma produced by the partial melting rises to fill the gap. And in this insert here, you see the red material freezing as it rises in cracks as these plates pull apart. And one thing that's not surprising is that above these zones, these narrow zones, you have high heat flow. And so that's a little more detail on what happens at a spreading ridge. Now, catastrophic plate tectonics is similar to conventional plate tectonics, except the plate velocities are about 1 billion times higher. During the flood, the plates were moving at about 5 miles per hour instead of about 2 inches per year as they move today. And that motion, by the way, is verified by thousands of GPS stations across the face of the Earth. These GPS stations document that the plates are moving in a plate-like fashion, and we know the speeds to very high precision from these GPS measurements. But how would it have been possible for the plate speeds to be 1 billion times higher than they are today? A very key question relating to the flood. Well, laboratory experiments show that mantle rock weakens dramatically under stress, at stress levels that can exist inside the Earth. And it's this weakening of rock in the mantle that provides the potential for a runaway catastrophe. I'll have a little more to say about that in a moment. But before I discuss that, let's consider how much continental motion occurred during the flood. The following sequence of images summarizes how the continents have moved just since the time when the supercontinent Pangaea existed, as reconstructed by the secular earth science community. So this is from about halfway into the flood. We're only looking at the last half of the flood in these images. So here's one taken when Pangaea existed. All the continents were together. A little bit later, early Jurassic, mid-Jurassic, late Jurassic, early Cretaceous, mid-Cretaceous, late Cretaceous, end Cretaceous at the Cretaceous tertiary boundary, Oligocene, Ice Age, just after the flood, and the present day. So let's just run that backwards. And all of this motion of the continents occurred during the year of the flood, based on the fossils that are on the continents. Again, that sequence is within the span of time of fossil-bearing sediments on the continents. Because fossils are indicative of the portion of the geological record associated with the flood, all the plate motion showed in the preceding sequence must logically have accompanied the flood and unfolded in the span of a few months' time. Now, catastrophic plate tectonics, like conventional plate tectonics, accounts for the mid-ocean ridges, the deep ocean trenches, volcanism adjacent to the trenches, and the global distribution of earthquakes. There are, however, some geological processes that are special and distinctive to catastrophic plate tectonics, such as supersonic steam jets emerging from the seafloor along 40,000 miles of rapidly spreading mid-ocean rift zones. And this is an attempt to depict these supersonic steam jets. So as the plates are rapidly pulling apart, much more rapid than they're pulling apart today, you have a large amount of molten magma that rises to the surface and is in direct contact with the ocean water. And it changes that ocean water. It almost instantly flashes to supersonic steam that rips up through the ocean and entrains liquid water in the fringes of the jets, which then falls back to the earth as torrential rain. So that's one of the features, and we're in the process. I'm working with a student here at Liberty who's well underway in actually modeling the details of these steam jets. But a crucial physics issue here is how can ocean plate sink vertically through 2,900 kilometers or 1,800 miles worth of mantle rock in just a few weeks' time? How is that possible? I've already given a quick answer. The ocean plates can slide into the mantle and sink because, first of all, because they're cooler and denser than the mantle rock beneath. But more importantly, rapid plate motion can occur because mantle rock weakens under stress. So how do we know that? Well, first of all, let's look at a sample of the upper mantle, what the upper mantle consists of. It typically consists of green olivine crystals, those green crystals shown here, mixed with black pyroxene crystals. So this is a sample of mantle rock that was explosively ejected from deeper in the mantle. These samples are rare. There's only some certain circumstances where they have been brought to the surface. So how do we determine that mantle rock weakens under stress? Well, for almost 50 years now, laboratory experiments have been measuring the deformation behavior of mantle minerals. This is an apparatus that was constructed in Paris, France, for just one example, one laboratory in the world that built this type of machinery. Here, stress is applied to the sample and to the sample in the center of this cylinder. The cylinder is referred to as an oven that carefully controls the temperature, and stress is applied to the sample by these silica rods that enter the top and the bottom. So the sample is put in the oven. It's brought up to temperature. Stress is applied to the sample for a specified length of time, and then the temperature is reduced and the sample is retrieved and then examined under, in this case, by electron microscope. And here you can see, here's an image of the deformed surface of the olivine crystals. You see these lines. They correspond to planes of atoms that have slipped over one another, and they've behaved as like cards in a deck of cards. They've slid past one another to produce this pattern of deformation. And in some cases, you get deformation in both directions, and you get crisscrossing patterns like you see in the bottom figure. But through these kinds of experiments, the deformation properties of these mantle minerals has been very carefully and thoroughly characterized. And this is from a paper, a 1983 paper. So already by 1983, enough measurements were available to generate plots like this one. I won't try to describe it in detail, but there are three different deformation regimes that were discovered. One, referred to in the lower left, is the diffusional flow regime. This is where individual defects like an extra atom or a missing atom in the lattice is caused to migrate because of the stress. And it generally results in very slow deformation. In the sort of the middle right, those lines are from laboratory measurements, and that deformation is referred to as power law creep. And the rate of deformation is given there in those numbers on the plot: 10 to the minus 4, 10 to the minus 6, 10 to the minus 8. That is the regime that we need for catastrophic plate tectonics to occur. So the very regime that we're interested in for that mechanism have actually been measured in the laboratory. It's because the deformation rates are high that you can measure them in the laboratory. They happen fast enough where they can be measured in the laboratory. So this regime has been well measured in the laboratory over the last 50 years. And then there's another regime at the top called low temperature plasticity, which operates at even higher rates of strain. So I'm just mentioning here that using this slide to mention that these quantities have actually been measured and are well accepted throughout the earth science community. Again, what we're measuring in that case were these green crystals, the olivine crystals. Now, back 25 years ago, I was able to take these measurements and put them into a 2D calculation, finite element calculation, where I allowed the rock to deform and looked at the behavior. And actually, the runaway behavior occurred. And so here's, in this case, I used a grid that was cylindrical in shape. Here a color is denoting the temperature, and the arrows are denoting velocity. And this is a snapshot just after this blue blob at the top, which I used to initialize the calculation. The bottom of that blob is just above the lower mantle, what would be the lower mantle in the earth, where we know that there's a tendency for slabs to accumulate. Anyway, with an initial condition like this, it doesn't take long for this situation to go unstable and runaway to kick in. And already at this point in the calculation, the velocity is up to 1 meter per second, which is like 2.5 miles per hour. That blob is starting to run away and sink. And this is a little later. The peak velocity has gone up about a factor of 2.5. Plus we have a hot blob at the bottom that is beginning to run away as well. So these are snapshots. This one is at 10 days. This one is at 30 days as this runaway process unfolds. And cold material from the top boundary is plunging down and spreading over the lower boundary. and the hot material from the lower boundary is rising up to the surface and spreading across the upper boundary. I want to emphasize that one of the consequences of replacing cold rock at the surface with hot rock, if the surface is covered with water, that the hot rock is going to have a lower density. It expands, and so there's going to be if it's covered with water, the sea level is going to rise because the sea bottom is going to rise because of the expanding hot rock. So this is a natural mechanism for causing flooding of the continents. I'm not showing continents here, but if there were, they would be flooded. So here's an animation showing that calculation, and what it shows is that using real physics and real measurements, we get this runaway behavior. The simulation, although it's only 2D, demonstrates that the physics indeed works. Specifically, that stress weakening in rocks can produce catastrophic consequences in a planet with the gravity field of the Earth, with the mass of the Earth and the gravity field of the Earth. Now I want to show a 3D calculation that makes use of the Terra program that I developed as part of my PhD research back in the early 1980s. And this is a cutaway view of the computational grid that Terra uses. Actually, these days I can use a grid that's twice as fine in all three directions. That grid has 10 million cells. And actually, I'm able to run one with 80 million cells these days. And with the one with 10 million cells has 32 radial layers, and the one with 10 million cells has 128 vertical layers of cells. And on each time step in this calculation, Terra solves the equations of conservation of mass, conservation of energy, and a balance of forces on each cell at each time step. And therefore, it allows a dynamic solution to unfold. And I just, for any math geeks in the audience, these are the equations that Terra solves. The force balance equation on the top, the mass conservation equation below it, and then the energy conservation in terms of changing temperature. And so anyway, I just want to emphasize that there's careful mathematics in this code that's implemented. Now, the case I'm going to show you, I initialize it. I'm able to have plates, include plates that I represent as a set of particles over the surface of the Earth. And I use an initial condition that mimics Pangea, that's roughly midway in the flood, although catastrophic plate tectonics began at the onset of the flood. I'm only able to model the last half of the flood for various reasons. Mainly, I don't have a good initial condition for what things were like at the beginning of the flood, but I do have a reasonable estimate for the midpoint of the flood. So that in the computer model, this is the way that the continents are approximated at the beginning. The dark lines represent the continental boundaries. You can make out Africa and South America there, as well as India, Antarctica, Australia, Greenland, North America, Greenland, and Eurasia. And to get the calculation started, I need to have something to make things a little unstable. So I put I put some cold material representing subducting plates around the margin of much of Pangea, and then a line of subduction from southeastern Asia down into where Australia is today. And this material is about 400 degrees colder than the surroundings, and it penetrates to a depth of 400 kilometers. This is a cross section through the Earth that shows that cold material just penetrating a little way down, but that's enough perturbation to get motion started in the physical domain, and from there the solution develops. So this is the solution. I'm allowing the plates to break apart, and so you can see. Okay, so here, yeah, let me run that again. You see they're breaking apart roughly, like we know they did break apart. This is a cross section through the equator of that solution. The cold material from the top is plunging down through the model and through the mantle and spreading across the boundary between the core and the mantle. And this is a view from the North Pole, again with the plates moving very close to how we understand they moved during the flood. And this is from the South Pole. Again, it shows that this solution unfolds, where we're simply applying these conservation laws, these well-known, well-accepted conservation laws, basically how we do computational fluid dynamics. So is there evidence supporting a recent episode of catastrophic plate tectonics? Yes, seismic images of the mantle reveal a ring of unexpectedly cold rock at the bottom of the mantle, beneath the subduction zones that today surround the Pacific Ocean. Now, these are what are called seismic tomography images, using seismic waves to take a 3D picture of the structure of the mantle. It's similar to medical tomography, which uses X-rays. In this case, earthquake waves are used, and some 10,000 or even more today, 20,000, 30,000 individual earthquakes are used, and all that data is crunched together in a big program using supercomputers to come up with these images. The blue here represents cold material that's at the bottom of the mantle. The red features, and I might say we're looking at the Earth from the two sides, two opposite hemispheres, Western hemisphere on the right, Eastern hemisphere on the left. And these red features correspond to hotter rock, hot material that's been squeezed up from below, squeezed up like toothpaste, and rising. Apparently, this cold material sinking down from the top has squeezed together this hot material that was at the core mantle boundary into these red features. Now, shocking, when these images first began to be published, this work was first able to be done in the late 80s and early 90s. This finding was shocking, mainly because of what kind of temperature difference these images imply. What's actually measured is seismic speed, but seismic speed is strongly dependent on temperature, and so it's possible to convert those seismic speed differences to temperature differences. And when one does that, one infers a difference of about 3,000 degrees centigrade. Now, that's about all the difference there is today between rock at the Earth's surface in the lithosphere and rock at the bottom of the mantle. So that was that was very startling. People found it impossible to accept. So it implies again that the temperature of the blue ring of rock is nearly the same as that of the lithospheric rock near the Earth's surface today. So, but if conventional plate tectonics were true and the plate speeds were like we see at the Earth's surface today, it would take some 100 million years for a slab to penetrate all the way down to the bottom of the mantle. And by that time, it would be largely, the temperature would be largely equilibrated, and it would not have this large difference. There wouldn't be these large temperature differences. So that the small amount of heating in that blue region is powerful evidence for an episode of runaway subduction in the Earth's very recent past. It's evidence that coal rock from the Earth's surface somehow has made it down to the bottom of the mantle in the very recent past. So needless to say, this was very exciting evidence that emerged in the 1990s, and I started talking about back in those days. So one thing I haven't explicitly mentioned, but what is the energy source for all of this deformation, all this movement of rock? Well, the energy driving the process is just the gravitational potential energy associated with the initial temperature differences. The cold rock at the top has a tendency to sink. It has gravitational potential energy relative to the base of the mantle. The same is true for the hot rock at the base of the mantle relative to the surface. So that potential energy can drive a mantle overturn where the cold rock dives down and covers the bottom of the mantle. The hot rock on the bottom of the mantle rises to cover the top of the mantle. So it's simply gravitational potential energy due to the temperature differences that's driving this motion. But there's some further obvious questions that people wonder about. One is, how were the continents flooded? And next, what caused the waters to then drain away? And another is, by what means was the huge volume of fossil-bearing sediment generated, transported, and deposited? Well, very quickly, I've already said a little about what caused the flooding of the continents. The answer to that is that rapid emplacement of cold, higher density ocean plate with hot, less dense ocean plate adjacent to the mid-ocean ridges caused the volume of the ocean basins to diminish. It caused the sea level to rise and water to spill onto the continents. So it's basically the replacement of coal rock beneath the ocean floor, which had a higher density and a smaller volume, with hot rock, which has a lower density and a larger volume. And it just caused the ocean bottom to rise by about 2 kilometers, about a little over a mile. The ocean floor rose, and that pushed up the sea level and caused water to spill onto the continents. So again, it's this process of replacing cold rock at the surface with hot rock from the core mantle boundary that causes the sea level to rise. But what caused the floodwaters then to recede? Many lines of evidence indicate that after the 150 days during which the waters prevailed on the earth, God caused the newly generated ocean plate to cool toward its present state. This cooling reduced the volume of the ocean floor rock. It caused the ocean floor to subside, and the global sea level then fell by some 5,000 feet, and the waters retreated from the continent surface. So that's we in this scenario, the water for the flood was simply the water in the ocean basins before the flood, and which is the same as the water in the ocean basins after the flood. There was likely a little bit of water that came out as the volcanic rock erupted. There is a little water in this volcanic rock, but though that amount of water is negligible compared with the amount of water in the oceans. So when that water ran off, huge volumes of sediment were stripped away after all this sediment had been deposited. And these horizontal black arrows show the sediment that was just stripped away just in this part of the western U.S., forming what's called the Grand Staircase. There are a few little isolated places which indicate that this entire sediment sequence was originally deposited way further to the south, but has since been stripped away. So there's evidence of thousands of feet on average of sediment being stripped away from the continent's surface at the end of the flood. And this sediment now is located on the continent's on the continental shelves. Here we see, this is a photo from Bryce Canyon showing the spectacular erosion. The rapid drop in sea level led to rapid runoff of the water and produced these very delicate structures in the sediment. The last sediment to be deposited was not well cemented in this area, and it left behind these very delicate spires in Bryce Canyon. But it indicates a dramatic and sudden runoff of water in this region. And just to the south, we see similar evidence of erosion that has carved Monument Valley, scoured the surface, hardly any loose sediment anywhere, and evidence of rapid removal of sediment, rapid erosion of this landscape. And it turns out that most of the Earth's surface today is scoured in this way. Right where I live in Virginia, in the Piedmont area of Virginia, if you were to take away the woods and vegetative cover, you would similarly see a scoured landscape, a result of the runoff from the flood. So the entire continental surface was scoured at the end of the flood. So what about the sediment record itself? Well, as I mentioned earlier, the Grand Canyon provides a representative glimpse of that record, of these sediment layers that blanket most of the continental regions of the Earth. So now I want to talk about how was this sediment record formed during the flood. This sequence of layers consists of sediment particles of sand, silt, clay, and carbonate that have been suspended, transported, and deposited by rapidly moving water. So a paramount issue is that a truly effective defense of the flood cries out for a reasonable explanation for how, in the span of only a few months' time, such a huge volume of fossil-bearing sediment came to blanket the continents in this orderly pattern we observe today. This is a map of the sediment thickness globally. On average, if we average over the continental surface, there's 1,800 meters. That's over a mile of sediment that blankets the continent surface. The thickest accumulations, as you can see, are on the continental shelves. And the thicknesses go up to 15 kilometers. That's some 10 miles vertical thickness of sediment that was eroded, that was deposited in an apron-like way around the continents. And some of the richest oil deposits are in these sediments at the edge of, on the continental shelves today. So again, by what conceivable means was all this sediment generated, transported, and deposited? The short answer I'm going to provide right at the beginning is that tens of thousands of mega tsunamis were responsible, and that these tsunamis were produced by the locking and unlocking of rapidly subducting lithospheric plates during the flood. So let's look at the power of tsunamis in today's world. In 2011, there was a huge earthquake off the east coast of Japan, magnitude 9.1 earthquake, most powerful earthquake ever recorded in Japan. And it represented, what produced it was 160 feet of slip between the overriding plate on which Japan is a part and the underlying Pacific plate, which is thrusting beneath the continental plate on which Japan is situated. And again, this earthquake triggered a devastating tsunami that reached heights of up to 133 feet above sea level and traveled inland as far as 6 miles. So here's a photo as the tsunami is coming over the seawall that had been built to protect the coastline from tsunamis, but obviously it wasn't designed for this large of a tsunami. And you see buses and vehicles being just tossed about like toys by the tsunami. And then here's a little bit later, you see the seawall there in the background, and the tsunami is coming, rushing inland, destroying essentially everything in its path. There are only a few steel reinforced buildings that are able to survive and not be completely destroyed. This is a photo of the destruction that the tsunami produced as it came inland about 6 miles. More of the damage. There were about 16,000 people confirmed dead, about 2,500 people missing, presumed dead, and on the order of 130,000 buildings totally destroyed by this tsunami. So how are these tsunamis produced today? They're generated in subduction zones, where most of the time the overriding plate is locked against the sinking subducting plate along the fault that separates the two plates. When the fault unlocks, the overriding plate springs back to its unstressed shape. The resulting slip between plates can produce a significant uplift to the sea bottom, which can generate a tsunami. So again, most of the time the plates are locked. When the stress gets high enough, as that subducting plate is moving downward continuously, as the stress level gets to the breaking point and breaks, the plates slip relative to one another. The elastic energy stored up in that overriding plate relaxes and restores the shape of the original plate, punches up the water that's in the trench and creates a tsunami. Again, this summarizes what I just said. Here in A, we have the fault locking, a little bit of orange there at 1. In B, we have the stress building, the tip of that overriding plate being deformed downward, the extent of that highly stressed area increasing. In C, the stress is reaching its limit, and then in D, the fault slips. The overriding plate springs back like a spring, and to its original shape, punches up the water that had been in that trench, and launches a tsunami, as you see in E, which travels in both directions. Generally speaking, that it's most destructive, more destructive on the side adjacent to the land. So, do we have evidence of tsunamis during the flood? Well, a major discovery from the seafloor back in the 1960s was the phenomenon known as geos. They were named back then for Geo Hall at Princeton University, where one of the researchers worked, named after a French geologist. These are now known as table mounts, but they're still called geos. These are volcanic seamounts whose tops have been beveled flat by wave action. They're significant because they so clearly document the reality of extreme tsunami activity during the flood. Here are two examples. The big one is known as the Gifford Geo. The other one is not yet named. Both are located about 700 kilometers, roughly 400 kilometers east of Brisbane, Australia. They're about 3 kilometers, their tops are about 3 kilometers above the bottom of the ocean, adjacent bottom of the ocean. And the dates of when their tops were beveled off is middle Miocene, in other words, near the end of the flood cataclysm. And this bigger one has a surface area of about almost 400 square kilometers, which is a significant area that was beveled away. A large portion of the top of that seamount was cut away. Here are some other examples of geos in the Pacific. Most of their tops are some 1,200 to 1,600 feet below sea level. They look just like that Gifford Geo. And there's relatively large numbers of seamounts in the Pacific, and some of these are flat top geos like we just looked at. There's a total of about almost 300 geos in the world's oceans. More than a third are in the North Pacific, a large number in the South Pacific, some in the South Atlantic and also Indian Oceans, and a few in the North Atlantic. And one of those is the Bear Seamount just off the coast of Massachusetts. And its flat summit is about 3,600 feet below sea level today. So there's evidence that the sea bottom just off Massachusetts during the flood, that sea bottom was near the sea level, and it has since sunk down to 3,600 feet below sea level. So geos affirm the reality of ferocious tsunamis during the flood. The fact that during the flood, the ocean basins, it also affirms that during the flood, the ocean basins were much shallower than they are today, and that the continents were flooded. So the cause of the sinking of the sea bottom was the cooling globally of the ocean floor. And where these geos are, the ocean floor subsided substantially, such that they are commonly 1,500 meters or about 5,000 feet below sea level now. All right, so now I want to show a numerical strategy for giving insight into the physical processes responsible for that, for all that sediment. And starting about 12 years ago or so, I started putting together a numerical model, which I named Mabul, which is the Hebrew word for flood. It was based on a code I developed at Los Alamos in the early 1990s. This solves the shallow water equations on the surface of a rotating sphere. It uses the shallow water approximation, which treats the water on the surface of the earth as a single vertical layer, but allows it to have variable thickness by having a variable bottom height at the bottom of the water layer. And that single layer, that makes the computation more tractable, less expensive. I use the same grid as I use in Terra, and this particular grid has, the grid that I use has 160, almost 164,000 cells, 4 times the number that's shown here. And because if I showed all of them, it would just be a black disk. The average cell width is about 60 kilometers across the face of the earth. So this model assumes that the dominant means for sediment transport during the flood was by turbulent, rapidly flowing water. So I use what is known as the theory for open channel flow, open channel turbulent flow, to treat that sediment. And these equations for open channel flow provide a realistic means for modeling sediment transport and deposition in turbulent flows shown here. So these equations have been benchmarked very well for actual situations like this one. And so they're used widely in the engineering geology community. Now, as for erosion, I assume cavitation to be the dominant process, and not only for degrading crystal and bedrock, but as well as also for eroding already deposited sediment. Cavitation is a process where bubbles of water vapor that form in regions of pressure, strong pressure differences, these little bubbles that spontaneously form can collapse, and when they do, they collapse violently, produce stresses on any nearby surface strong enough to shatter all the silicate minerals that exist, and also cause severe damage to ship propellers by that same process, as you see here. Now, so I use that for the erosion in the code. Now, in the last several years, I've included a model for the continent motion, which seems to be pretty important. So here is a little animation of that motion that's folded into the Mabul code. So I'm modeling as the tsunamis are happening. I have the continents moving, as I just showed there. And then as to the tsunamis, I have repetitive tsunamis generated by rapid plate tectonics. So I have some subduction zones in the ocean part of the model that produce periodic subduction. And this is a little video I made that shows the result of these tsunamis. This is a plot of water depth above the land in meters. The red is clipping the values at 200 meters. Zero is zero depth. And so at this stage in the calculation, the water had not fully covered the continents. It was in the process of submerging the continent. But the point here is to see the time variation of water depth as a result of these tsunamis. So you can see it's a very dynamic process. Water coming in and sweeping over the surface and bringing sediment, depositing it, moving out again. Now here's the initial topography. So I simply assume linear topography from the continent edge to the center of the continent. And the maximum value shown in red is about 1,000 meters, or about 3,000 feet. So this is just a very crude representation. I can probably improve on it using some hints from geology, but this is just a placeholder for a topography model for these continents. So now I'm going to show snapshots of the calculation at several points in time. The first is at 20 days. And so here is a plot of the land or surface, or the water height or surface height, whichever is higher, and it's clipped at 1,000 meters. So you see these wave-like features there in the Pacific on the west side of the supercontinent. Those are being generated by these tsunamis. I also have some tsunamis generated in the other hemisphere, but the overall depth in this dynamic calculation of the water is low. So for some reason, dynamical reason, the water is temporarily low in that part of the Earth. I've got the Coriolis force is operating, so it influences how the water sloshes around. An equal area projection is on the left. A view from the North Pole is shown on the right. And okay, and this is showing the cumulative bedrock erosion at 20 days, and the red is clipping at 100 meters of erosion. You can see that erosion is concentrated to the edges of the continent here. So the edges of the continent are being very severely and rapidly eroded. This is the net cumulative sediment deposition at 20 days. And you see the deposition is occurring along the edges of the continent, where those waves are able to reach inland but are stopped by the higher topography. Okay, here's a snapshot at 80 days. And similar result. Here you see this block that had been against the southern part of this initial supercontinent has migrated northward, about to slam into Siberia and become the China block in Eurasia. Here's the erosion at 80 days. The maximum value now is at 400 meters. Again, intense erosion around the edges of the continent. This is the cumulative sediment deposition. And now the amount of sediment on the continent, the average depth, average over the entire continent, is 581 meters, although the center part of the continent is basically barren of sediment. Here's 120 days. You see how much continent motion has taken place by this time. Still have the tsunamis in the oceans. The continental regions are starting to turn yellow and brown, which means there's a lot of sediment now deposited on the continents. This is the cumulative erosion, and this is the cumulative sediment deposition. Now the average is 825 meters. And that red strip in Eurasia corresponds to the edge of the two blocks before they slam together. So there's the eroded edge is covered now with a substantial amount of sediment. That depression has filled in with sediment. This is at 200 days, and now you see sediment has covered the continent surface. Much of the continental surface is now covered in sediment, thick sediment. This is the cumulative erosion. This is the cumulative deposition. The average is just shy of 1,500 meters, average over the continent. And this is at 220 days. And I didn't even notice it when I presented these results in 2018, but I later compared this result, the result of the calculation, with the sediment distribution on the continents today, and found, although it's far from perfect, there's a great deal of resemblance. In other words, today there's hardly any sediment over most of the interior of Africa, and almost no sediment over the Indian subcontinent. That's also true in this model. And a lot of sediment over Eastern Australia and none over Western Australia, which is true. In the case of South America, the eastern part of South America is barren of sediment for the most part, but sediment on the western half, and that's true. And similar for North America. So, and similarly for Antarctica as well. So even though it's well, I count it amazing, astonishing that there's anywhere near this good of an agreement, given how crude the numerical model is at this point. So some encouraging new insights from this simulation. One is that tsunami-driven cavitation erosion is sufficient with this mechanism to account for a sizable fraction of the entire sediment inventory in the fossil-bearing sediment part of the record. Next, it shows that the water speeds that from these tsunamis were sufficient to sustain the level of turbulence needed to suspend and transport and deposit so much sediment over the continent interiors. And finally, the tsunami-driven flow can account for the coherent patterns with large horizontal dimensions that we see in the actual sediment record. And then I already mentioned this correlation with today's sediment distribution, which is extremely encouraging. So the details of this calculation, these results were presented at the 2023 International Conference on Creationism by myself and a colleague, Evan Navarro. It's in the proceedings. These papers are posted online or for free and can be obtained from the Digital Commons website at Cedarville University. And also encourage you to visit my website at globalflood.org. Now, Jesus clearly affirmed the reality of the flood. In Matthew 24, he says, "For the coming of the Son of Man will be just like the days of Noah. For as in those days before the flood, they were eating and drinking, marrying and giving in marriage until the day that Noah entered the ark, and they did not understand until the flood came and took them all away. So will the coming of the Son of Man be." So he's putting his stamp of authority on the reality of what is described in Genesis concerning the flood. He's also saying that the days before his second coming will be very similar to the way it was in the days of Noah, which is a sober warning to us today, of course. He has similar words in Luke 17, where he says, "And just as it happened in the days of Noah, so will it also be in the days of the Son of Man. They were eating, they were drinking, they were marrying, they were being given in marriage until the day that Noah entered the ark and the flood came and destroyed them all." So I encourage all of us to add a strong defense of the flood to our apologetics toolkit. So let's pause here and take and open it up for questions. If anyone has any questions, I turn it back to Donny.
Dr. Baumgardner, that was an excellent presentation. Exactly what I was looking for. Comprehensive. And to those in the audience or who might view this later, if you're objective and you are a skeptic, you currently reject a global Genesis flood, that should change your mind. That was fantastic, John. And we've had a lot of audience engagement, a lot of audience interaction, a ton of questions have come in. And so I think, John, we are going to have a rigorous discussion here, and I'm excited. We can make this one of those go-to videos for people on catastrophic plate tectonics and the flood. Firstly, I want to give some of my own comments and feedback. So again, fantastic presentation. I really liked the way you started, where you pointed out the reality of the flood based on a few basic general observations in the earth. For example, the famous quote, but it's so true, John, billions of dead things buried in rock layers laid down by water all over the earth. It really is that simple and that obvious. We find these sedimentary rock layers that extend over entire continents, marine fossils in landlocked areas that are far from any body of water. And so the evidence really is all around us. And then you got into very thoroughly the CPT model, predictions, expectations. And I appreciate the fact that you answered a lot of the most common questions that people have. What was the source of water? What created the sediments? And so I appreciate that. We do have lots of questions on those that we can expand our thoughts a little bit. And so you mentioned in your presentation, and I was wondering if you could expand on it a little bit, the weakening of the mantle rock in terms of explaining how meters per second movements of the plates rather than continental drift, we're looking at continental sprint, could have occurred. And if I heard you correctly, you said that we have observational evidence for the possibility of this in real-time experiments in the lab. Is that true, John?
Yes. The earth scientists have been interested in how the mantle deforms, how plates generally penetrate the mantle. And so there were, as soon as this concept of plate tectonics emerged, that provided a lot of incentive for earth scientists to conduct these experiments and measure the temperature and stress conditions, measure how deformation occurs under the conditions estimated to exist inside the earth. So there are many labs, dozens of labs around the world undertook these kind of experiments, and they compared the results. And like I said, already by 1983, they were publishing review papers, reviewing all the data from these labs and trying to put it together in a single paper, summarize it in a single paper. And that figure I used was from one of those review articles. And that those studies have continued now for the last 40 years. 40 years has elapsed. It's hard to believe. Since 1983, 42 years. So there's lots of data on how rocks behave under these conditions that are estimated to exist inside the earth. So one of the type of experiments that were not done explicitly were, well, no, I'll backtrack on that. That region in that little graph that I showed, where it said laboratory rates, that was an experiment where the rocks were being deformed at the speed that they would be deformed under catastrophic plate tectonics, and their strength was actually measured under those conditions. So those experiments have been done and published. So yes, those conditions have been modeled, reproduced in the lab, and the measurements made.
That's incredible, John. And another fascinating point along these same lines of real-time evidence and confirmation of CPT and the flood itself, and I'm wondering if you could expand on it a little bit, the cold slabs. And so what appears to be a fulfilled prediction of the model, John, because the cold pre-flood ocean, if it sank only just 4,500 years ago, and the cold slabs that you pointed out in many different pictures using seismic tomography that they find deep within the earth going down miles are still cool. But if those were taken down there, John, millions of years ago, would they not have melted, or at least
they would
become the temperature of the surrounding material?
They would have, heat would have been conducted into those cold slabs, and they would have temperatures comparable to the surrounding rock after that long a time. Yes.
So would it be accurate then to say that what we find in terms of these massive slabs of cool rock that we find them deep within the earth? Again, I mean, it's just amazing observations there. Would that be accurate to say that that is a confirmed prediction of aspects of CPT?
Well, I would soften it a little bit, mainly because there's so much controversy still after, 35 years after this was pretty well, published and pretty well known in the earth science community of this, the situation that those images, seismic tomography images that I showed, that's more or less been known throughout the earth science community for a good 30 years, if not 35 years. And back then it caused great consternation. People just didn't want to believe it, couldn't believe it. And that state of affairs really hasn't changed. There are papers published in the last year that are still basically just desperation attempts to try to account for that reality. They basically attempt to argue that the differences in seismic speed is mainly due to a difference in chemistry, and yet they can't get that to work. And they of course rule out of hand that it's not temperature differences. So about the only other thing they have is composition differences, chemical differences, and they're hard pressed to get that to work. And so there are still fairly prominent papers being published. Just it hasn't ceased for the last 35 years because nobody can solve the problem, mainly because it's absolutely off limits to understand it as as temperature difference. So they've got to explain it some other way. And the main thing they're focused on are these, what in my images were those red features. And they have a special name for those now. And it's LLSVP. They're called LLSVPs. That stands for large, low shear velocity provinces. And it's technical jargon that puts off the average person. They have no idea what that might be from those words, but basically it's a blob of rock that has low seismic velocity, and in particular the shear waves propagate slowly. The compression waves do as well, but it's clearer, more evident with the shear waves, seismic shear waves. So these are called the large, low velocity shear, large, low velocity shear wave provinces. And you can Google that online and you'll get a slew of papers that have been nonstop since the 1990s. I guess that one of the main ones came out in 99, but they were already very concerned prior to that time. So the secular community has no good solution when, from a catastrophic plate tectonics point of view, the solution should be obvious, that these low shear velocity features represent material from the core mantle boundary, which you might suspect has, prior to the flood, might have a little different chemistry from the rest of the mantle above it was squeezed together by the sinking, subducting slabs, and now are concentrated in these two regions, one beneath Africa and the other beneath the South Central Pacific. And so this is probably one of the top controversial issues still in the earth science community. Just what are these things? How did they arise? If they are, of course, one obvious thing is if they are thermal, and if they were buoyant, they should have risen to the surface and caused all kinds of havoc if the Earth is more than a few thousand years old. So I believe that when they first were formed during the flood, they did cause a lot of havoc. They are responsible for the huge number of seamounts in the Pacific Ocean, these volcanic these outpourings of lava that produced the 50,000 or so seamounts on the Pacific floor. So I believe it did produce a lot of havoc when they were first formed. But most of that lava that was produced has risen to the surface and turned to rock. But it's a huge problem. One of the biggest problems with solid Earth geophysics, accounting for these features.
So you're not compelled or convinced by the secular explanations for the existence of these cold slabs, John?
No, and neither are the secular people. They're not. Nobody's satisfied with anything that's been proposed as yet. So I'm not satisfied with any of their explanations either. I believe it's primarily an expression of the subduction around the present day subduction zones that occurred during the flood, and it represents. So we've got a ring of cold material that is pressed together the prior hot material that covered the core mantle boundary into these features that are, sort of look like squeezed up toothpaste.
Would a good illustration to make the technical aspects of this point more understandable, would it be akin to if I had a hot coffee, my wife made me one, let's say, and she put an ice cube in it? Well, if I came back to the coffee a minute or two later, it's likely the ice cubes will still be there. They're not going to be melted. But if I came back 5 hours later, well, then the ice cubes would be non-existent. So if the ice cubes are there on a hot coffee, it suggests they were just put there recently. The cold slabs deep within Earth, near the mantle, the fact that they're there and they haven't either warmed up or melted suggests that they were taken down there just thousands of years ago. Would that be accurate, John?
Yeah, I think that's a reasonable example, a reasonable illustration of what I'm talking about.
Yeah, that's a really good piece of evidence. So if a skeptic...
Let me say that the rock is a extremely poor conductor of heat. It's an electrical and a thermal insulator, and so heat does not travel through the rock well at all, and just to I recently did a quick calculation of how long it takes to cool a slab of ocean floor. And let me try, I just did that a few days ago. I'm trying to remember. Yeah, to cool, if you started with a temperature profile like we see near a mid-ocean ridge today, and wanted to cool it down by using just thermal conduction of heat to the temperature profile that we see in a region away from a spreading ridge, say 1,000 miles away from a spreading ridge, and just use normal values for the thermal conductivity of rock, it would take 63 million years to cool that slab to its present temperature.
Wow.
And so That's and so this is a problem for any flood model. It appears that the today's ocean floor, all of it that's at the surface today, has cooled from a very high temperature state at a mid-ocean ridge. Originally had a temperature profile like we can measure today, estimate today from below, just below a mid-ocean ridge. It somehow has cooled down to a temperature that causes that plate to be effectively rigid 1,000 kilometers away from the ridge, and pretty rigid down to a depth of, say, like 80 kilometers. Well, because of the small conductivity of rock, it would take something like 65 million years for the rock to conduct away the heat through the surface to get the temperature down that much. So that's an example of how slowly rock cools. Or, we're at the bottom of the mountain, we're talking about heating up a rock. So it would take a similar amount of time to take a slab that's, cold and at the Earth's surface. If you put it down at the bottom of the mantle, it would similarly take something on the order of 60 to 100 million years to heat it up again, to the surrounding temperature. So that's why this is such an issue. Why it's such a problem. I was going to start to say this is an issue for any model of the flood, unless you're going to deny that the ocean floor, today's ocean floor, was formed during the flood.
Right. Which you presented in your talk, evidence somewhat recently where the ocean floor today is relatively young.
Yes. Because there's many ways we can estimate the age of the ocean floor. I served on the radioisotopes in the age of the Earth team back over the interval 1997 to 2005. And, we addressed just why is it that radioisotope dating methods consistently give ages that are way beyond what's in the Bible, right? Ages that are millions or tens of millions or hundreds of millions, or in some cases more than 1 billion years old. What is where, if the Bible is right, where is the error that these scientists, what is the error the scientists are making? And our rate team, we felt like God gave us the answer to that. And that was very rapid nuclear decay during the flood. And that wasn't just some ad hoc conclusion. It was a conclusion we claimed we could demonstrate from the research that we did during the rate project. And so that's our answer, that there was a huge amount of nuclear decay that occurred during the year of the flood, something on the order of 500 to 600 million years worth of decay at today's measured rates. That was a dramatic thing that occurred during the flood, and something that seems to require God's supernatural intervention. Now, many people, are uncomfortable with having God intervene supernaturally in nature and during the flood. But 2 Peter chapter 3, verses 3 through 6, to me, very strongly implies that God acted supernaturally during the flood. Peter uses the flood as a counterexample to the claim that all continues just as it was from the beginning of creation. He's refuting that claim by the scoffers. He says they're going to come in the last days. They're going to claim, you don't need to worry about Jesus coming back or any of these kind of claims. Have been no supernatural interventions by God in the history of the world. And Peter's response is, don't be so quick. You're willfully being willfully ignorant of God's intervention during creation in the affairs of nature, and also his intervention at the time of the flood. So if that passage says that God intervened at the time of the flood, just what type of interventions do we find evidence for? And I point to two, and I mentioned these two in my 1986 paper, the very first paper on catastrophic plate tectonics. One was an acceleration of nuclear decay, and two was the rapid cooling of the ocean lithosphere. And that still appears to be the two major things that are required. And now that we have, with the rate work, we realize there's another sort of the other side of the coin to the accelerated nuclear decay, and that's the accelerated removal of heat from that accelerated nuclear decay. So whether or not that was just part of the same process or something else, that supernatural activity had to occur, the removal of all that heat from the rapid radioactive decay. Otherwise, Earth's granite would have been vaporized by the accelerated nuclear decay. So there's an absolute imperative of also rapid removal of heat during the flood, from that accelerated nuclear decay.
Some very good points there, especially the scriptural point. 2 Peter 3 predicts that in the last days there's going to be scoffers denying three things: the special creation, the world that then was being overflowed with water that perished, the global Genesis flood, and the coming judgment by fire. And so if we are going to argue against the global Genesis flood, John, due to some of these reasons related to heat and radiation, well, what does Peter say? That those scoffers are willingly ignorant of what God has done in the past. And I find it interesting because some want to propose a local flood, but wait a minute, the special creation was universal, which scoffers deny. The coming judgment by fire will be universal. Very few, I think, would say that the coming judgment by fire would just be to a local city somewhere in the States. No, this will be a universal, worldwide judgment by fire. And so the middle event that scoffers deny, the Genesis flood, again, the world that then was being overflowed with water that perished, why would we ever insert local flood there? The other two events, they're universal, right, John?
Yes, of course.
And so that middle event, that second event that scoffers deny, why would we insert local flood there? No, that would therefore also be universal and worldwide. And so I'm curious as to your thoughts, Dr. Baumgardner. There are many videos out from critics, including naturalistic evolutionists who deny God in general. They will say, well, flood geology or catastrophic plate tectonics, it's not a scientific model because it does require at least a couple miracles. What would be a good way to engage that assertion, John?
Well, first of all, I'm unashamed concerning my allegiance to Jesus. I'm unashamed of my belief that the Bible is the supernaturally given Word of God, and it and as such is inerrant. At least in its original manuscripts, there are no errors there.
Amen.
And so it plainly teaches a global flood, and just in the same way, I feel no need to apologize for these things. I believe the case for both these propositions is as solid as that I could ask for, and so I'm not rattled. I mean, the Bible talks about the passage we looked at, that there are going to be scoffers. There are going to be people that scoff at the things of God,
right?
Scoff at the existence of God, scoff at the Bible. So why be surprised at that?
I've heard Dr. Andrew Snelling, and I've read it as well. I have a book beside me called Rock Solid Answers. And he pointed to several lines of evidence for accelerated nuclear decay in the past, which largely answers the question that skeptics typically challenge us with. Why do lower rocks date older than higher rocks? And so what has been pointed to are fission tracks, radio halos, and helium and zircon crystals. I'm fascinated by all three, and I know you've given talks on all three from my understanding. But I've heard Dr. Snelling specifically say that if there were not some way of supercooling the planet where there's accelerated heat and accelerated decay, there should be accelerated supercooling, because we wouldn't have these lines of evidence for accelerated decay like fission tracks and radio halos, because they are obliterated at relatively low temperatures. And so there must have been a way, perhaps supernaturally, that this heat and radiation was dealt with. John, are you familiar with those comments? And I was wondering.
Yes, I was part of the team. Those were issues we grappled with, and that was the answer. We speculated that the cooling might be just the other side of the coin of the process God used to accelerate the nuclear decay, that they might have been two aspects of the same intervention on God's part. So I don't have a problem with saying that was a miracle. I believe God's word is true. I believe in the supernatural. I believe God has intervened supernaturally. You believe that if you believe Jesus rose from the dead, did the miracles that he did. So I don't apologize for talking about miracles or defending miracles in the context of the science that I do. So I don't apologize. I don't believe a Christian needs to apologize. A creation scientist needs to apologize for accepting miracles. I mean, if you're a believer, you accept miracles. It seems I can't imagine somebody that's a true believer in Jesus who denies the miraculous. And so I see it as somewhat schizophrenic for a person, a Christian, to have a problem with miracles during the flood, or miracles in the context of speaking about science and the Bible.
Right.
So it's just the secular mindset that they completely reject miracles in any context, any circumstance. So I say, that's their problem. That's, if you understand what God's revealed in his word, and you're starting to see how it's confirmed in nature around us, and you accept the supernatural, why is there any argument? Why is there any discussion on that point? That would be my attitude on it.
Well, that's why I'm flabbergasted or baffled when I see old earth creationists or theistic evolutionists, those that claim right off the bat to believe in God and the supernatural, when I see them invoking a challenge to us as young earth creationists regarding miracles pertaining to heat. I guess I can kind of understand when a secularist has a problem because they're denying miracles in the first place. But a professing Christian attacking the reality of miracles, that baffles me a little bit, John. And
yeah, it's understandable. I mean, I understand it. And as a fairly young Christian, when I started grappling with these things, I had some of these same kinds of struggles, but it didn't take me long to realize that, you don't go part way in on the Word of God. You either
all in or all out.
Yeah.
It's not Costco. This isn't a free sample. You're all in or you're all out. And so here's a good question. I'll start bringing in some of our audience questions. This relates to what we were just discussing on accelerated nuclear decay. Maybe to set the foundation a little bit more, John, for those that want to deny the flood because of heat and radiation, isn't the burden on them, though, to address these lines of evidence, such as the existence of radio halos, helium and zircon crystals, and fission tracks? Because if those three observations and realities suggest accelerated nuclear decay in the past, don't skeptics that deny that have to offer a superior explanation for those points, John? Does that make sense, what I'm saying?
Yes. I would say, one of Andrew's projects, sub-projects during the RATE project, was his work on polonium radio halos. And those are, in the secular world, are considered, that how they formed is a complete mystery still, unexplained. They have absolutely no mechanism. And even for creationists, it's non-trivial to find a way that these could have formed even during the flood. But Andrew persisted, and he went out and actually he collected the rocks. He broke the rocks open, extracted microcrystals, biotite crystals from them, examine these biotite crystals under a microscope, and by hand, individually identified 30,000 halos, radio halos. I can't even imagine a human being able to do that, and he did it. And he worked hard to come up with a mechanism,
right?
A viable, defensible mechanism for how this could possibly happen. And he made some discoveries that no one thinks he found that no one else had noticed. No one had done enough work to even detect it, that these halos seem to be concentrated at the cores of granite plutons. These bodies of granitic rock that came up as very viscous magma, rose up and formed a plug-like structure, and then cooled. Well, it turns out that the water, that this magma contains quite a bit of water, and in the cooling process, that water breaks out, is lost from the rock. And so there's a lot of this it's magmatic water that comes out of a cooling pluton. And he found that it was in that context, in the center of these plutons, where there would be an abundance of this magmatic water. That's where he found these polonium halos. And so that was a huge tip-off as to the mechanism and the context in which these halos formed. And so and so that led him to the mechanism for producing these halos. And so the constraints are pretty extreme for these halos to not be annealed, by heat, for the heat not to destroy them and all the damage to be erased. The temperature has to stay below 150 degrees centigrade.
Right.
So and as this pluton cools, there's not much time left after the temperature gets that low. So the window for forming these polonium halos is very short, very narrow. But anyway, the conditions that allow these halos to form in the natural world, in the physical world, are very special. And he was able to zero in on what the conditions were, where you would expect to find it, and indeed demonstrated that that's where these polonium halos are found, then it helped him hone the mechanism and put more constraints on what's needed. You have to have a lot of polonium in solution, probably radon, which is a precursor to polonium. It's dissolved in this kind of a magmatic fluid situation. So you've got to, and then you've got to have some way to scavenge, to pull these polonium atoms out of solution. And it's known that sulfur atoms, if there happen to be some of those around, they will tend to grab on to the polonium atoms. And anyway, he came up with a scenario that seems to be the only one that anybody has proposed that has any plausibility at all. And my point is that it's a very special situation. It requires accelerated nuclear decay to generate such concentrations of polonium to start with. And you got to be in a situation where you have molten granitic magma around, and you're in a situation where you're cooling that magma, and you're tending to concentrate magmatic fluid in a certain region of this cooling rock mass. So anyway, it's an example of heroic, persistent research and a lot of field work and study, and a lot of physical exertion to process so many rocks. So anyway, it's I give him, it was a heroic effort on his part.
Amen. That's creation scientists doing real science, and praise the Lord for his diligence and efforts. And so that makes me think that this situation is comparable to, let's say, the origin of life or the origin of DNA, where the secular camp has no good explanation for the complex, sophisticated nature of DNA and life. And so the best explanation would be a supernatural one. Well, in light of just one example that you've gone over here, John, and I wonder if you would agree, the existence of these polonium radio halos and how they necessitate accelerated decay in the past. Okay, so if that's what the evidence suggests, that's what the data suggests, but a lot of heat and radiation is produced. Well, perhaps the best explanation for how we get rid of that heat and radiation is a supernatural one. Or else how do we explain the existence of things like polonium radio halos? John, what are your thoughts on that?
Well, I think it's good to be humble and be honest that, yes, as far as we can tell, you do need that supernatural element here, that component of the supernatural, to get the accelerated decay and also remove the heat.
Right.
And as far as the radiation is concerned, perhaps the water provided a radiation shield around the ark, and shielded the sea life sufficiently where the radiation wasn't that big of a problem. But if not, maybe that also required, as you're saying, a supernatural explanation, supernatural solution. So anyway, like I say, I'm the science that I do. I don't just willy-nilly invoke a miracle if I'm having a problem, if I'm facing a challenge. It's only when it looks like it's a stone wall where there is no other way. It's only in those kind of situations do I suspect that it was God's intervention. And way back in '86, I concluded there were two things of this in this category: the accounting for all the radioisotope, all the daughter products we see in rocks, and the other was had to do with cooling the ocean lithosphere. And so I haven't I really haven't added to that list in the last 40 years. Those are still the main items on that list.
I think those are some great thought-provoking answers and back and forth, John. And so Winsberg Sandbox has an interesting question on this topic. And so I appreciate it, David. So he's wondering, Dr. Baumgardner, why would God cause accelerated nuclear decay in the first place to happen during the flood? What would be a good reason for this, John? What are your thoughts?
I guess I haven't really pursued it to see if I could come up with a good reason. So I offhand, I can't come up with what good purpose would accelerated nuclear decay have for the creation, for God's creation. I don't, if you're looking for a cause, I think of Isaiah 55, where it says that God's thoughts are higher than our thoughts, his ways a lot higher than our ways, that they're, or Deuteronomy 29:29, the secret things belong to the Lord our God, but the things revealed are for, I can't remember the exact wording, for our sons. Well, that there are two categories of knowledge, the secret things of God and then the revealed things of God. And so I'm not aware that he's revealed what he's certainly, I'll make this point, he certainly hasn't revealed everything. He's only revealed probably just a tiny amount of the truth there is out there. But we need to lay hold on the things that he's revealed and make sure we're walking in those things to the best of our ability. So in one sense, I can say, as far as I know, he's not revealed the answer. God's not revealed an answer to this question. And it might well be in the category of the secret things of God.
Well, the Bible does say that we see through a glass darkly, but then face to face, we'll understand a lot of these things that we might not know now. And so I've seen some creationists say, well, accelerated decay, God could have invoked accelerated decay to get the plates moving in the first place, since it would require energy and heat. But if I understood your presentation correctly, some of the aspects of it, John, you were invoking and describing scientific reasons for the plates moving, essentially.
Yeah, that's right. I think just using normal science, we understand how the plates moved and even how they moved very fast during the flood. We don't need to invoke any miracle. There's good science, I believe, that accounts for those things. So that's not something we need to invoke a miracle for.
Wouldn't the geologic features of the Earth, anyways, John, require these meters per second movements through the floodwaters, continental sprint, I've heard it described, just to bring up these mountains, the necessary force of these plates coming at each other to rapidly buckle the rock strata to uplift these mountains, as compared to continental drift, these snail pace movements through the Earth with these plates would be like two cars coming at each other at 1 kilometer an hour. The impact is not good. There's not going to be much of a result there, but you got two cars coming at each other at 100 kilometers an hour. Well, that's going to be devastating. And so I guess to sum that up in a question again, aren't catastrophic plate tectonics required anyways to explain a lot of the geologic features we see on the Earth, John?
My reaction is probably not the kind of features you're trying, the kind of picture you're trying to paint. The main difference is accounting for how you could open the Atlantic Ocean. If North America was adjacent to Europe and Africa, just in the middle of the flood, how are you going to move them apart, during, subsequent, or how are you going to move them apart during the time frame of the flood to where they are today?
Right.
You're going to have much higher plate speeds. So that's a very simple response, very simple answer, just to move the plates around as they moved, as we have evidence in today's seafloor as how they moved. Just to do that in the flood time scale requires plate velocities on the order of a meter per second, or a couple of so miles per hour. So you just calculate, take the width, the distance from the mid-ocean ridge to the to the coast of North America, and I believe the flood seems to require that happening during the flood, and you can just estimate what the speed of motion has to be. It's just that simple. So we're not talking about any crashing into something, any kind of deformation that requires these higher velocities. It's mainly just moving the plates around to where they are today in the time frame of the flood.
Okay. Yeah, that makes sense. And so would you have, because I was looking at your visuals throughout your presentation, would the pre-flood world, the supercontinent, would that have been Rodinia-like? And then if I understood correctly, during the flood, as plates are moving rapidly, you'd get something like Pangea, but then that would move apart. Would that be accurate, John, that you have something like Rodinia, but then Pangea?
I haven't written a separate paper on that. I probably should, but I've included it in these papers on the tsunamis. I've included my continent motion model. And one thing I discovered, I can't remember how long ago that was, 10 or 15 years ago, I discovered that the supercontinent that I believe was in existence at the onset of the flood, which some people refer to as Pan-Oceania. Pan is Pan-Notia. Notia means, see, I already forgot what that means. It means that all the continents were together in the south. So that there's some complications I don't think I want to go into right now, but so that what I found was this secular model, the secular supercontinent that existed in their time frame about 600 million years ago, which they refer to as Pan-Oceania. It's distinct from Rodinia. That supercontinent, if you rotate it, let me get my numbers right. If you take an axis perpendicular to the Earth's spin axis, and basically in an eastward direction, if you rotate Pan-Oceania 110 degrees clockwise about that axis, it maps almost perfectly onto Pangea. So I believe the pre-flood supercontinent resembled Pangea closely, and there's just one block, or mainly the block that corresponds to the North China block and the South China block today in Asia. That block seems to have migrated from the eastern portion of Gondwana during the flood up to a more northerly position. But other than that, the two supercontinents are essentially identical. During the Paleozoic, for example, Gondwana was intact. There was no change between Pannotia and Gondwana, and Pannotia and Pangaea, as far as Gondwana is concerned. Gondwana was intact. It was in same supercontinent. It didn't change between Pannotia and Pangaea, and the northern continents, Laurentia, which is North America and Greenland, Baltica, which is Western Europe, Siberia, which is Eastern Asia. All those blocks did not change either between Pannotia and Pangaea. So basically, and I don't know anyone else in the world who has pointed that out, but I've been emphasizing it in my papers for the last, I forget, 5 or 6, 7 years. And so I believe there wasn't a lot of plate motion in the Paleozoic. I believe that the motion was a result of what's called true polar wander, and so anyway, and the true polar wander is responsible for this 110-degree migration of that I referred to earlier, that maps Pannotia right on top of Pangaea. So anyway, that's my position as far as the pre-flood continent is concerned. And this is important enough, I should write a separate paper laying that out clearly and not confusing it with other issues. But I haven't had time. I just haven't gotten that done yet.
Yeah, there really just isn't enough time in the day for us to get everything done that we want to, but I'll be one of the first to read that, John. And so those are some interesting points. What about those in the world of young Earth creation, our fellow brothers and sisters, who are skeptical of Pangaea and a supercontinent in the pre-flood world? Where could we point to in scriptures to show them that a supercontinent in the pre-flood world, before the flood took place and these plates moved apart, is justified?
Well, I look to the account in Genesis 1 of on the third day of creation. And on the third day, God says, let the waters which are below the firmament be gathered together into one place, and let the dry land appear. And so it appears that the waters together in one place refer to the pre-flood ocean, pre-flood, single large ocean. Now, if there's a single large ocean, it's not required, but it would be plausible that there might well be a single large continent mass. There's right. Be a supercontinent as well. So I believe it's perhaps hinted at in that particular verse. And so one thing we note is that the Earth's continents are made out of a very special kind of rock, a rock that consists primarily of quartz and feldspar. And as far as we know, that composition of rock does not occur anywhere else in the solar system, or as far as we know, anywhere else in the universe. It seems to be, as far as we know, unique to Earth, and it forms a layer about 20 miles thick, maybe average might be a little more, 21 or 22 miles, 35 to 40 kilometers thick. And where that layer exists, you have a continent. And where that layer does not exist, you have a deep ocean on the surface of the Earth. It's sort of that binary situation. If you have that layer, it's typically on the order of 20 miles thick, and you have continent. If you don't have that layer, you have deep ocean that's about 4,000 meters, about, between 12 and 13,000 feet deep. So you've got a very sharp distinction between those two types of Earth's surface, either deep ocean or continent. And the continent is made out of this very special rock, generally granitic in composition, high fraction of feldspar, and usually there are two kinds of feldspars, and then you have about on the order of 27. I forget. Then the rest of it is quartz, and so and if you look at meteorites, we haven't found a single meteorite made out of that kind of granitic rock. There was a rock on the moon found made out of it, and so the secular people speculate that was launched by a large impact on the Earth, and launched into space from Earth by a large impact, and it was captured by the moon. I think that's a reasonable explanation, because we haven't found any other examples of granitic rock on the moon. Not that impact might not have lofted some other pieces that made it to the moon, but so far in our limited exploration of the moon's surface, nobody noticed any. So anyway, there's special. This kind of rock is very special to the Earth, and so it appears to me that when God writes there in Genesis 1, and let the dry land appear, that dry land corresponds to this granitic rock that makes the continents today. So
that's unique to the Earth, found nowhere.
And it's unique to, and it seems to be unique to the Earth. The scripture doesn't indicate that it's unique to the Earth, but just our exploration suggests that it's unique to the Earth. The meteorites and the asteroids and comets that we've sampled are made out of rock, a different chemical composition rock, the kind of rock that we find in the deeper mantle, made out of the kind of rock where the dominant minerals are olivine, like I showed, and pyroxene. Those very rocks I showed in my slide presentation. Most of the, well, as far as I know, all the rocky meteorites are made out of that kind of material. Some have been, some there's water on meteorites, on asteroids, and so some of the minerals have been influenced by the water, but they're still, the basic chemistry is still the same of these as olivine and pyroxene. So anyway, it appears that the other rocky planets also are made out of that ultramafic material, it's called, or don't have any granitic rock. There's no indication there's any rock like that on Mars, or to the extent that we've looked at Mercury, no indication that it's there. And so anyway, yeah, that's I believe the continents are something pretty special, and a pretty special aspect of the Earth, and it allows us to have this massive amount of water. If the continents weren't as massive as they are, we couldn't have as much water in the oceans as we have. So it appears that I don't know all the reasons, but apparently, the Earth is so well designed for life that there was a reason that he designed it with so much water on its surface. And like I said, for you to have any land, the continents have to be a certain thickness. It appears that this is another example of fine tuning. So,
Yeah, that's an excellent example of fine tuning, one that I'm going to adopt and now utilize moving forward, John. And so those are some fantastic points. You mentioned the large the large ocean that would have existed in the pre-flood world. And I'm curious because I've heard some creationists say, well, the pre-flood world, there weren't really any large oceans or a large ocean, possibly just shallow seas. But I'm wondering your thoughts, because wouldn't we require in the pre-flood world a large body of water, a large ocean, in order to hold what we see in the fossil record, these massive marine creatures like megalodon, basilosaurus, mosasaur, ichthyosaur? How could they be sustained or live in a pre-flood world that really only has shallow seas or no large body of water? That's always been a thought that I've had, John.
yeah, well, it would seem like to me you could have smaller oceans, deep enough to accommodate those large animals, those large marine animals, and not have the huge oceans we have today. So I don't feel like that's a it certainly eliminates having only shallow seas,
Right.
but I don't think it's that strong that we had to have the big oceans that we have.
Smaller oceans than we see today, but more than just shallow seas, basically.
Yeah. So I do think, I do suspect that because we see there's so much marine life in the fossil record, that much of the continental surface before the flood may have been in form of shallow seas. And so much of the lower part of the fossil record, it's almost entirely marine,
Right.
and much of it looks like it was shallow marine. And so that suggests to me that there may have been shallow seas on the margins of the continents. I'm not dogmatic about it, but other creationists have suggested that there were, for example, more of North America. Much of North America was a shallow sea before the flood. So I'm not a specialist on that. But my impression is, how I envision the pre-flood Earth is, I believe the fossil record is probably indicating that there was a lot of variation in topography, and the order in the fossil record represents, as sort of the, corresponds to the earlier ecological zonation model,
Right.
with marine life at the lowest elevations. Then we had a massive lycopod kind of forest, a lot of the kind of vegetation we find in the Paleozoic coal beds. Kurt Wise has argued strongly for floating forests.
Yeah.
And that's attractive to me to account for just the mass of carbon we have in coal on Earth. It seems like it would help account for that huge mass of coal if we had floating forest over much of the world ocean. But I haven't looked into it enough to have a strong position, but I'm inclined, to the extent that I have looked into it, I'm inclined to think the pre-flood world may have had these massive floating forests. And then a little higher on the continent, you had types of vegetation and environment to support the large dinosaurs, and then the mammals and the mammals were likely at high elevations that were separate from those environments, and this region where the mammals were may have been multiple places on Earth, but they were the last to be destroyed in the flood. And that's why the mammals, you find the mammals at the very top of the record. So, so it was, it'd be nice to have more detail about what the pre-flood Earth was like, but the fossils do seem to give us some pretty important clues.
Mm-hmm. Yeah, I think that's a good general overview. To recap a couple of your points: shallow seas on the margin of the continents, oceans, but much smaller than we see today in terms of the large ocean basins, massive floating forests, perhaps. And
I'm going to argue that because the mass of continental rock, I don't think has changed much from before the flood. That would imply that the volume of the ocean basins is probably very close today, very similar today to the way it was before the flood.
Okay.
And we just have just raising the sea level just a little bit could flood the continent margins enough to give you these shallow seas.
And then you've got tens of thousands that you mentioned in your presentation of these mega tsunamis worldwide, accounting for a lot of the sediment buildup, John?
Yes.
Okay.
And that's another issue whether there was a lot of sediment in the pre-flood world. And I don't exclude that. There are formations where you've got 20,000 feet or more, 30,000 feet of sedimentary rocks that have absolutely no fossils. The Belt series in Western North America is one example. And so there could well have been thick deposits of sediment that got formed on day 3 that existed and could have been a source of sediment for the flood. But I believe that Earth was so transformed during the flood that I'm not sure we have the data to argue one way or the other.
Right.
But some creationists suspect there was that a good part of the sediment in the present sediment record was in existence before the flood. My calculations show that that's not needed, that this mechanism, these large tsunamis, have the ability to break crystalline bedrock down into fine sediment particles. There's still a little bit of an issue with transforming them to clay during the time span of the flood, but I think that there are ways to accelerate for that process to unfold quickly. So I'm not convinced that is a problem, but we don't know. I think these are unanswered questions. There could well have been a lot of sediment in the pre-flood world on the continents where there was significant erosion during the flood, and that sediment was just deposited in the flood sediment record, redeposited in the flood sediment record.
Does the CPT model, catastrophic plate tectonics, have a good explanation for both chemical and fossiliferous limestone, John, in terms of accounting for the massive amounts of limestone that we see on the planet?
I would say no. That hasn't been not that it's not a very important issue, but it hasn't been something that I've been that concerned about. I haven't addressed it. We've had some colleagues as part of our Logos Research Associates that we tried to nudge into looking into the limestone problem, the carbonate problem, and that just never got traction. So it is a major area we would like find somebody to really jump into. But I've had some interaction with people that do have some knowledge of the salt formations. And so there's one individual who's a strong advocate that some of these massive salt deposits, that the salt was erupted from the mantle. And So I'm I don't know. First reaction is to be a little skeptical of that. I do know that catastrophic plate tectonics does have a source for a lot of salt, and that is that in connection with these geysers, these supersonic geysers that result from that occur along the mid-ocean ridges, that depending on the depth of the water over these ridges, the water can be deep enough. It needs to be 2,200 meters or a little more than that deep. The water, if there's enough pressure, the water becomes supercritical, and supercritical water loses its solubility. It doesn't dissolve salt. So the salt that's today dissolved in seawater, if you suddenly change the water to being supercritical, all that salt precipitates, falls out of solution, and you have you get, that's a way to create very quickly some very strong brines, salty brines at the bottom of the ocean, which conceivably can be incorporated into the rock record. So we need somebody to look into that. But there, at least in the framework of CPT, there's a mechanism for producing a lot of salt during the flood, and possibly accounting for some of these huge salt deposits. The massive amount of salt in the bottom of the Mediterranean Sea or in the Red Sea, for example. Anyway, there's no end to problems. There's lots of issues. There's lots of things that people interested in contributing to creation science can work on. In this case, the tasks are plentiful, but the laborers are few.
It makes creation science fun. I think it's a great time to be a biblical creationist because, as you're putting forth here, we have a lot of research projects that we can dig into. We need more researchers, and so I think that's a good answer. From my understanding, and I'm wondering where your thoughts are on this, that chemical limestone rather than fossiliferous limestone can be formed in environments like hot springs where mineral rich water evaporates. So I wonder if the fountains of the great deep that you were talking about in your presentation, which, correct me if I'm wrong, is largely magma but some water.
No, that's a misconception. These what I'm referring to, I mean, it's easy to interpret them as well. The scripture refers to fountains of the great deep before the flood. It says those fountains of the great deep were cleaved apart.
Oh, you're right.
And the flood ensued. So there were fountains of the great deep before the flood. And I would say there are fountains of the great deep now after the flood. The black smokers are a good candidate for being a fountain of the great deep. They're putting out hot water, lots of minerals. In many cases, the minerals have a lot of iron sulfide, and so these iron sulfide particles are black, so it looks like they're emitting smoke off the sea bottom, the mineralized water. And so, but during the flood, you have these patches, I would say these strips along the sea bottom, which are essentially molten rock. And immediately above those strips, that water is briefly becomes supercritical. But if there's much of a pressure gradient, that supercritical water quickly rises and explodes into steam, and its volume increases 1,000-fold or more, and very quickly. And so you end up with a steam jet and we're in the process of modeling those jets here at Liberty University. I hope to have some examples here in the next few months, maybe in the next month. Have a really sharp student working on it, so during the flood, if we're talking about fountains, these certainly ought to qualify because they're going to be the steam velocities are going to be supersonic. There's not enough energy for them to reach the Earth's escape velocity, but nevertheless they're going to go high into the stratosphere, and they're going to entrain a lot of liquid water as they come racing up through the ocean. They're going to, and our calculations show that indeed these jets do entrain lots of water, and they bring that water. That water is lofted above the ocean surface, and then there's some big blobs, some smaller blobs, but it implies there would be heavy rain as a result of the action of these supersonic jets.
So the result of those supersonic jets basically brings heavy rain down upon the Earth.
Yes, but it's not magma; it's water. It's not magma. Okay. There's no the density of molten rock is so high that it's going to basically more or less stay at the bottom of the ocean, at the ocean, on the ocean floor. It's not going to be a fountain of magma. It's the fountain is going to be the water, the steam that hot rock produces when it comes in contact with the ocean water.
So is it a mix then of water vapor, volcanic gases, and magma, basically?
No, what comes up is almost completely water vapor.
Okay, so then
steam. We'd call it steam. It's same as water vapor. Steam is water vapor, but it's supersonic steam at a moderate temperature. The calculation should tell us how the steam is expanding and cooling as it comes up, and so I don't yet have a good idea of the temperature of this steam as it rises. It's going to cool as it comes up through the atmosphere, but just how cool it gets, I don't know yet.
That's good. That's helpful, John. That helps me. I appreciate the clarifying points there. And so this comes in a few. Again, one thing I like about your presentation is it was comprehensive to the point where we answered a lot of the questions that came in, and then a lot of our discussion here has also addressed a lot of the questions and challenges that have come in. One being limestone, which came in quite a bit. And so, Andrew, coming here, this was earlier in your presentation, early into the presentation, that is, John. And so he's wondering, according to the CPT model, he thinks this is an issue. He says, if water currents were so fast over the continents, we should expect large-scale erosion. Why then are there more sedimentary deposits over the continents?
Okay, well, I'm still working on tuning the model. Basically, these tsunamis in the deep ocean, the speed of the tsunami wave, the main pulse of the wave, is given by to good approximation the square root of GH, where G is the acceleration of gravity and H is the depth of the water layer. So if the water layer is 4,000 meters in the deep ocean, if G has a number is 10, then the speed in meters per second is given by the square root of 10 times 4,000 are 200 meters per second. That's roughly the speed of a jetliner. So the tsunamis, it's well known that tsunamis in the deep ocean travel at about 200 miles an hour. So if you have a tsunami off the coast of Japan, the time it takes for it to reach Alaska or even South America, you can just calculate it, take the distance and divide by 200 meters per second. And but when the tsunami gets on land, its wave speed goes way down. A factor of, depending on what the water depth is, but factor of 6 or 7 or so. It goes from 200 down to maybe 30 meters per second. And so I don't know what speed this caller, Andrew Cumming, I don't know what kind of speed he's talking about, but basically this model of open channel flow accommodates these kind of speeds and these kind of sediment loads. I show in my ICC paper that you need, on average, I forget the exact number, something like at least 15 meters of sediment in suspension. That's on the order of 50 feet of solid material in suspension in your water column that's moving onto the continent, to get the amount of sediment transported and deposited on the continent we see in the sediment record. So we had the rate of I didn't give a good picture of how fast this sediment record is being laid down. We're talking about there's meters of it per day, of sediment deposition. And you saw how dynamic the velocities were. So that code is really churning to do all those calculations. I have something like 144 tsunamis in the span of 150 days. I said tens of thousands, but it's over 100,000, 144,000 tsunamis. And we've got water columns of, many tens of meters over much of the continent. So there's but what goes on at the surface is that sediment settling and more or less being laid down like a carpet at the bottom of the sediment column. Most of the motion, though, is at the top. Is the velocity profile has to go to 0 at the rock surface. So we have and it's well known that the velocity, the variation in velocity with height above the surface in these kind of continental floods, it decreases with a logarithm of height, or the velocity increases with the logarithm of height. So near the surface, the velocity it goes down to 0. You have a rigid boundary condition at the surface. So all of that's pretty complicated. And even though I have a moderately sophisticated model at present, I need an additional model to model that bottommost, what's going on when the sediment is depositing on the surface. That's a thin place in my model currently. I really need the kind of model that Steve Austin has talked about, where he's trying to model the nautiloid bed, and so it's there's a lot of physics that goes on in that very bottommost part of this flow. So there's a lot of complexity that I didn't even touch on in my talk on that front.
Yeah, in a way, it's almost a sneak preview into everything going on, because people like yourself, Dr. Snelling, Dr. Austin, and others are continuing to advance these models. And that right there is a good detailed answer, John. Appreciate it. And so here's another one. Solidify your faith. Appreciate the question. He's wondering, how does a tsunami flowing over solid granite rock erode away the solid granite rock?
Okay, I can give a fairly simple answer. The answer's a little more complex than this, but let me just say, when the velocity exceeds about 15 meters per second, you can be assured that cavitation kicks in. And cavitation is like a micro jackhammer. It is able to shatter all the, shatter quartz, shatter feldspar crystals. It will pulverize rock. And, if you're generating just a swarm of these small vapor bubbles because of the turbulence, you're going to, you can very effectively erode solid rock. Granite, basalt, it doesn't matter the rock type. So that cavitation process is very effective. It was demonstrated at Glen Canyon Dam? They're just above the Grand Canyon. Back, I think it was in the 30s. There was a large flood. They had to release a lot of water, and there was cavitation in those tubes that carried water from above the dam down to the river. And when they open the valves and let the water they needed to release, it just in a matter of seconds, cavitation kicked in and basically destroyed those tubes and eroded a lot of the rock material surrounding them. So it was a huge expense to repair all of that. Poured in, probably thousands of cubic yards of concrete to try to fill in the big holes that the cavitation had cut. So that demonstrated to a lot of people just how powerful a force cavitation could be in the geologic context. You could just annihilate steel reinforced concrete in seconds, and then erode huge holes in the bedrock around it. So if there was anybody a skeptic about the power of cavitation, they turned into a believer after they saw that.
Yeah, we at times underappreciate the force and what can be done. Hard to keep up on these comments, Dr. Baumgardner. You're a fan favorite, and you've sparked in your presentation a lot of interaction, a lot of discussion. And so this next one, Jeremy McLeroy, appreciate the question. And again, to the audience, I appreciate all the engagement, the support, and the back and forth discussion in our live chat. And so he's wondering, what is the mechanism for seafloor lowering after the flood tsunami cut off the now undersea mountains?
Okay, a good question. I glossed over that, but basically I see no other answer but the supernatural cooling of the ocean lithosphere after the flood. And it's given how warm that rock was during the flood, it's easy to cool it enough to drop the world sea level by 5,000 feet. So I believe there was that kind of intervention on God's part to cool the ocean floor, which deepened the ocean basins and provided room for all the water on the continents to drain off. And it stripped, in so doing, it stripped away huge amounts of sediment. And, much of that sediment, much if not most of that sediment now is on the continental shelves. And it's, a source for a lot of oil around the world today.
Very good. Appreciate that, John. Here's another one that came in from Andrew Cumming. And so here's his question. If all that basaltic crust formed in less than a few months, why are some parts of the ocean floor so much denser and different in their geologic texture compared to other parts?
Well, I would argue that the ocean floor is amazingly uniform over all the Earth. There is a difference between the Atlantic and the Pacific, in that the difference is the spreading rate along the mid-Atlantic ridge is only about a third or less even than the spreading on the East Pacific rise, which is producing, the west limb of it is producing the Pacific plate, and resulting in a pretty high plate speed for the Pacific plate as it moves northwestward. And so the features there around the ridge are much smoother because of the higher spreading rate than they are adjacent to the mid-Atlantic ridge. But apart from that, the ocean floor is relatively the same over most of the Earth. In the Pacific, you have a higher density of these seamounts, these volcanic seamounts, and that seems to be associated with that huge blob of strange material that the secular people are calling the LLSVP piece. It appears that when that first appeared, there was a lot of melting in the mantle and a lot of volcanoes produced on the Pacific floor. But those are the primary differences. The overall, though, the ocean floor looks very similar. Evidence of seafloor spreading along ridge segments that are offset by transform faults. That's the general pattern of the ocean floor. And so, regardless of where you are, the Arctic, the Mediterranean, the Pacific, the Antarctic, the Atlantic, the seafloor is more or less the same.
Well, you've clearly done your homework, Dr. Baumgardner, on this information. David Winsberg has a question here. David actually published a couple technical papers in the latest ICC on the heat problem. And so those were interesting. And he's wondering, John, if you've considered the effect of the Coriolis force in your models.
Yes. In my tsunami modeling, I include the Coriolis force. So that is fully represented, accurately represented in the model.
Appreciate it. I don't think we got to this one, but let's double check. Solidify your faith. Appreciate the question. How do convection currents work when the crossover density forces magma to sink instead of rise?
Okay, that's a good question. This crossover density is a very special situation. You've got to have the material as in a molten state and not the solid state. And the mantle, except for some tiny patches near the surface and perhaps maybe a few little patches on the core mantle boundary, everywhere else, the mantle is solid crystal and rock with interlocking crystals. It's not a magma. It's not lava. It's crystal and rock with interlocking crystals. In some cases, the crystal size can be large, can be, even an inch or more across for individual crystals. So this density crossover doesn't apply to solid rock at all. So you can just scratch that as applicable to the mantle today. or even during the flood, because the mantle was not molten during the flood. We're sorry, the mantle is it's far enough away from the melting temperature throughout that you don't need to, except near certain places near the surface, near the Earth's surface, does the actual temperature of the mantle get close to the melting temperature. But elsewhere, it's far enough from the melting temperature that you can forget about significant melting in the mantle, and you're having to deal with the mantle as a melt. Only if the mantle is melted in molten state does this crossover density come into play.
Very good. Appreciate that, John. Here's an interesting one from Robin. Thank you very much, Robin, for the question. How does Dr. Baumgardner's model account for large asteroid impact craters, such as the Chicxulub crater on the Yucatan or the Vredefort site in South Africa? What are your thoughts on that, John?
Okay, well, I believe that the Chicxulub crater was definitely an impact crater, a pretty large object, and it would have occurred during the flood, before the peak of the flood in the Cretaceous. So it was one aspect of the flood. There seems to be evidence there were quite a few impact events during the flood. And so it appears that the solar system was not as stable as it is today, and it was responsible for a spike in impacts during the flood. I don't have an explanation for that. It's something that I think remains, it's a good research topic to try to understand that. On the other hand, I don't, like some creationists, want to have all the cratering that we see in the solar system take place during the flood. I don't think that's defensible. I don't think that's possible to successfully defend either. But on the Earth, there were higher frequency of impacts than we observe today, to be sure. All right, so the Chicxulub impact, I believe, was a impact during the flood. The Vredefort impact, I believe, first of all, that it is a crater. It is a result of a large impact in South Africa. And from all I can determine, it appears to have happened, before life was created on Earth. Now, I know this causes a lot of heartburn, or at least heartburn for some creationists, to think that there could have been, God could have created a perfect Earth, even a perfect universe, a perfect solar system, and there would be any scars or any craters. I don't think Scripture requires that. Nowhere in Scripture does it require that. It's just an interpretation. When God says that what He made was very good, that's I don't know that it requires that what He had created had no impact craters associated with it. Now I know some of my close friends will get upset with that comment, but my position is I like to call it like it is, and these do appear, as far as the record is concerned, it does appear that these craters occurred before the flood, before the geology associated with the flood. And so that crater, along with the Sudbury crater in Canada, appear to be craters that occurred had to occur, I believe, occurred during creation week, early in creation week, before life was created on Earth, before plants on day 3, and before sea life and animals were created on days 5 and 6. Now, I'm certainly open to being corrected, I know it's not pleasant to be corrected by God Himself, but I welcome. It says a wise man receives instruction, receives rebuke. So if the Lord wants to rebuke me on that, I want to be I want to be right. I don't want to be wrong. So I welcome correction. I welcome correction if I'm incorrect. But to me, just taking all the evidence into account, it appears that the Verdefort impact structure had to be on day 2 or 3 before life was formed on the Earth. And similarly, there's this issue about when was the moon cratered?
Right.
Was it during creation week, or was it during the flood? And just based on, I give some credence, pretty strong credence to that radioisotope methods do give correct relative dates. They certainly don't give correct absolute dates, but they appear in most cases on Earth to give correct relative dates. And if that is applied to the moon, then the moon appears to have been cratered before the flood, and that has to be during creation week. So I'm answering some questions that I haven't been asked. I may be getting into a little trouble on this. But, that was asked here, and what I just said is related to that.
Right. It is. And it keeps it comprehensive. You rebut or answer possible questions that could ripple out of this. And what you said is interesting, because and I don't think, based on what you said, that it would go against, I'm just brainstorming here, I don't think it would go against the very good creation, because you pointed out that a lot of these impacts could have been before day 2, 3, 5, and 6. And so before life, including plants. And so the negative effects, I guess, of those wouldn't affect life. Maybe it'll give the Earth and the moon a little more personality too, before creation event is over. So it's an interesting point to consider. We've discussed it here on the channel before. We did a program with Mike Ord on the geology of Mars, and we got into the moon. And if I remember correctly, he made very similar points to what you said there. And so I appreciate that, John. I think those are some interesting points. And so, okay, this next one here, I might mess up a couple of these words. Forgive me. A lot of this is technical, but this is good. This is what we need, John. Tolkienomics. Appreciate the question. He's asking, are major bathymetric features, such as the salt plates above the Sigsbee escarpment, indicative of a rapid catastrophic process or a slow deposition model?
Okay. I'd have to Google that. I'm not sure where it's something in the ocean. I'm fairly sure. I'm not sure where the Sigsbee escarpment is.
Looks like it's a feature of the Gulf of Mexico.
Yeah, it's now called the Gulf of America.
Right. Yeah.
I'm wondering. There's certainly the Whopper sand represents a very rapid event, a deposition of sediment event in the Gulf of Mexico, and results. It's almost certainly a result of the massive early runoff from the flood in mid-continent North America. Just a staggering amount of sediment washed out of mid-continent North America to the south into the Gulf of what is now America, Gulf of America. And so I would suspect that that this salt feature is also a result of those processes that occurred, catastrophic processes that occurred during the runoff phase of the flood. But I would have to look at details. That's not something I know about. But just the general setting of it, knowing that it's the Gulf of Mexico, is that it almost certainly is a catastrophic result of a catastrophic process and not slow deposition.
Very good. I appreciate it, John. Now, this one came in the form of what's called a super chat on YouTube when we do these live. And so it's people sending in a donation to get their question asked. You and I, John, we discussed this for quite a bit after your presentation. I'd say probably about 30 minutes. But to respect the donation, we'll put it up here. And if there's anything you wanted to add, feel free to do so. Aiden Dragon, appreciate the support for tonight's program. It's been very edifying, John. A lot of positive feedback. And we got a good mix of critics too, which is good because we want to answer your challenges, objections. We want to leave no stone unturned and hopefully plant some seeds. It's important. And so he says, if rapid nuclear decay was caused by God, why? We did engage that a bit earlier. Is there a benefit from it, or are we just claiming that an unknown natural process caused by the flood?
Okay, we did talk about it earlier, and my answer then was I can't provide a good reason why God would cause so much nuclear decay at any time during creation or during the flood. So I can't come up with a positive benefit of that. I haven't given it a lot of thought, but none occurs to me now. And I'm not, in discussing this with my colleagues in the past, I can't ever remember us coming up with some positive consequence of that.
Appreciate it.
And then are we just claiming that an unknown natural process caused by the flood? I don't. I see the accelerated nuclear decay as, for the most part, something separate from the flood itself. It did coincide with the flood. I don't see that it played a significant role in the other aspects of the flood, and I don't think it was a natural process. I believe it had to be a supernatural process. So that's my answer on that one.
You mentioned we can be okay or confident with relative ages, just not absolute. And so, correct me if I'm wrong, John, is this why when a critic asks, why are lower rocks in the geological rock strata, why do they date older than rocks at the top, higher in the geological column? Is that because during the flood, the lower rocks, the earlier rocks are experiencing more hits of accelerated decay than the rocks that are laid down later in the flood?
Yes, the simple answer is yes. That this decay is a cumulative situation. You're accumulating daughter products as a result of the decay, and if you all of a sudden have some melted rock appear on the scene during the flood that doesn't, where those daughter products are not present, once that rock solidifies, those daughter products start accumulating. And if you date that rock, it's going to have a younger date than a rock that was that's crystallized, solidified, crystallized earlier. So it's just the reasoning for giving reliable relative dates is that these daughter products, you're primarily measuring the amount of daughter products, and those just accumulate with time. Once if there's some process that has homogenized, mixed things together, usually there's some means where the clock is reset when the rock gets melted and recrystallizes. So that in effect resets the clock to zero. So there's a very plausible reason why the relative dates, why these methods should give fairly consistent, reliable relative dates.
Yeah, that makes sense. And so when it comes to, because earlier we talked a lot about polonium radio halos, when it comes to the helium and zircon, and I know you gave a talk on this, but in a nutshell, like an elevator pitch, is the reason why this is good evidence for accelerated decay because helium's a slippery molecule, and we still find helium in zircon crystals, but we also find trace amounts of lead, telling us that there has been decay from uranium to lead. But if these zircons are really billions of years old, there really shouldn't be as much helium as we find. And so the only way to explain that basically is accelerated decay to retain the helium, but also explain the lead from decay, from uranium to lead decay. Would that be more or less accurate, John?
Yes, I'd say that's a general, that's pretty good description. The key there is that we can in the lab we can measure how fast helium leaks out of zircons, how fast helium diffuses through the zircon crystal. There are some subtleties. I don't want to deny that, and I don't want to get into them here. But basically, our measurements demonstrated that the helium in the samples we measured from northern New Mexico, from Fenton Hill, they should not have retained their helium more than a few thousand years, given how the measurements that were made on how fast the helium was migrating through the crystal, and but both the lead, both the amount of helium and the amount of lead pointed to an age, if we're using current day decay rates for uranium. If those rates had been constant through time, that rock should have been 1.5 billion years old. There was that much lead there, and there was also almost that much helium there. But the rate that the helium leaks out indicated that those rocks were not 1.5 billion years old. They couldn't be much older than 8,000 years. And the statistical average number was about 6,000 years for the age, how long that decay had been going on to accumulate the helium.
It's a great answer. And from my understanding, Dr. Russell Humphreys put out a technical paper, published a paper showing why the amount of helium, and how you pointed out that we can measure the amount of helium as it dissipates, gives us about 6,000 to 10,000 years.
Yeah, that was in our rate report, which is downloadable online from www.icr.org/rate2. And Dr. Humphrey's chapter on the helium in zircon project is that's chapter 2, and you can download individual chapters from that report, that 800-page report. You can download the individual chapters now for free on that ICR website. And if you want all the details, I forget how long that chapter is. I think it's about 80 pages long, but if you want all the details on that work, that's the best place to go.
John, I really appreciate your time tonight. The time has flown by. You have great endurance. I know a lot of this was technical, and we had a good mix of questions from critics and non-critics. And so what we're going to do we still have a great audience, so people are enjoying this. We got to end it at some point. So we're going to wind it down with one last question. This was one of the first questions that came in, John, but I wanted to save it for the end. Why? Well, because it's kind of, it's related to another topic in a way from the flood, but it's also a hot topic, as a lot of people discuss on both sides the evidence for a young Earth from the C14 that we find in diamonds. And maybe to set the foundation, because I actually did a presentation, John, based on your work and a recent presentation you did at Logos Researchers. And so a lot of people are bringing up this paper to try and argue against the C14 that's found in diamonds. They're basically arguing it could be contamination. And so firstly, for the audience, I want to give a shout out to this article that you wrote a while ago, it seems, responding to this contamination issue here. Are the radiocarbon results caused by contamination? We know, in a nutshell, if diamonds really are billions of years old, we shouldn't find detectable levels of radiocarbon in them, because carbon 14 has such a short half-life. And so could you speak to this, John? Because a lot of people have this question. I've seen this come in through email, through Facebook, in comments as well. And they're wondering, so here's Andrew coming. He says, my question would be why he claims the silver powder was the source of C14 contamination in the Taylor and Southern 2007 diamond measurements. And that has to do with the article that I just put on screen, where you gave a bit of a response to that, John.
Okay. I'm not sure what the silver powder was that he's referring to. To the best of my memory, I don't remember that term even appearing in their 2007 paper. So I would need to, but let me just say that, in that paper, they considered all the possible sources of the C14, and they systematically eliminated all of the more common sources of contamination. Basically, when you put the diamond directly into the sample holder, into the aluminum sample holder, there's nothing there but aluminum and diamond, and you're blasting it with cesium atoms, and you're dislodging a few carbon atoms from the diamond that get ionized and directed into the accelerator, and accelerated to a modest fraction of the speed of light, and then put through a turning magnet, and the turning magnet changes the angle, the trajectory of a C14 atom differently from a C12 atom, because the C14 atom is more massive. It doesn't get turned as much, so it gets collected into the C14 detector. Okay, so the issue is why were there? Well, I'll put, the main issue then is why did Taylor and Southern get any C14 atoms at all in their detector? And they indicated they did. So where did that C14 come from? I say because they eliminated all the other potential sources, the only one left is from the diamond. And yet they were unwilling to acknowledge that. So it's just that simple. It's just that the answer is just that simple. They themselves eliminated all the other possibility, and so the only one left is from the diamond. That it was genuine C14 within the diamond, and now I'm trying to remember. I believe that when I had a lab do this same test, I think the lab had niobium powder in the sample holder to try to improve the thermal conductivity or the electrical conductivity. I can't remember which between the sample holder and the diamond. And they later determined that it wasn't necessary. But I think the measurements that were published did have that niobium powder. And so one possibility was that there was some atmospheric contamination of that powder, which I can't rule out. This was a long time ago. This was 2005, I think. So that was 20 years ago. I just can't remember the details. But
I wonder if this would help to clarify. If not, that's okay, because like you said, this was a long time ago. This issue has been engaged for a long time. And so he's saying when you didn't use silver powder, when you measured C14 in your diamonds, when you placed them in an aluminum holder, indicating this was instrument background. Does any of that sound familiar, John?
The normal, or about one of the main things that could be invoked is so-called instrument background, quote unquote.
Right.
But they eliminated most of those, most of the types of instrument background that could arise. So, I guess they're thinking about fluctuations in their power supply, or that really shouldn't cause atoms to go to the C14 atom collector. My answer is that the most plausible, because they eliminated all the other possibilities, the most plausible explanation why they still got atoms in their detector was that those carbon atoms were coming from the diamond. And they failed to acknowledge that possibility. But that's the obvious answer.
That's good. And so I guess the last thing I'll say on that, John, then we're going to wrap it up, for the audience, especially in terms of this specific issue. Do you remain unconvinced after all these years with the answers, or I would probably call a lot of them rescue devices, to the C14 that we find in things like diamonds, coal? So typically they looked at contamination, like here, background detection, environmental contamination. Some have said, like Reasons to Believe, have argued that nearby nuclear material in rocks close to the diamonds could recharge the C14. So the question is, do you remain largely unconvinced by those responses, John?
Well, I actually have another set of diamonds I would like to get tested if I could find a lab somewhere in the world to do it.
That'd be good.
The issue is that the levels that the previous diamonds we've had analyzed, the levels are indeed low. Some of the tests indicated levels that were high enough to be, not be some subtle aspect of the equipment. So I'm still trying to get a statistical. I've got 20 diamonds. I don't want this to get out, but I don't think it matters. I'll say that I'm trying to get these analyzed. I've got 20 of them. They're all, well, they come from a variety of locations. And I'm trying to treat them all alike, have the lab run them multiple times in multiple targets and look at the results, see if there's, trying to use statistics to eliminate, to identify if this is just random noise, or whether the signals we're getting are consistent from, run after run. And, that gets a little expensive. It's not real cheap to do these tests. And there's not many labs in the world that are willing to do this. And so whether or not before I die, if this happens, I don't know. If God, if God opens the door, it will happen. But it's a difficult, I'll just say it's difficult because these levels are indeed low. And it's not like measuring C14 in some archaeological site where you expect, a good fraction of the modern value to be there.
Right.
And you can date it within, maybe 20 years. It's not like that. We're talking about extremely small levels of C14. And you've got to have you need to have a fairly powerful accelerator. Some of these, we'll call them budget C14 labs, use lower energy devices that are cheaper to buy, and those are really not up to the task. And so, not any lab out there, not especially some of these commercial labs, not any lab is able to do this. And those that are able, many of them are not willing. Anyway, it's only if God allows it to happen, makes it happen, will we be able to get results that I believe we can defend, because it requires multiple tests, multiple samples, probably from the same diamond run many times, and just to get statistics, and it's expensive, and I need to raise funds for this, and so all these factors are making it hard to really resolve this issue of C14 in diamonds. On the other hand, C14 in normal fossils, I believe that the case is cut and dried. There's no reason to debate that. There's simply no way to account for all the C14 we find in almost any fossil that you want to test. It has way more 14. To have any C14 is unexpected, but the levels of C14 are so far beyond what contamination can explain. It's to me, it's not worth arguing about. You either accept it or you don't. If you reject it, okay. I'm thinking you're rejecting it for philosophical reasons, for ideological reasons, not scientific reasons.
I think that's an excellent answer, John. I've really appreciated your time that you've offered, not just myself, but our live listening audience. We still got roughly 70 live, with enough questions to keep us busy till same time next week, but we got to wrap it up at some point, John. I appreciate your knowledge. I do consider you a hero in the world of young earth creation, John. So praise the Lord for your work and the work from other creation scientists as well. John, this has been very comprehensive, excellent presentation. We've engaged quite a lot of the questions that came in, especially a lot of the pertinent ones related to catastrophic plate tectonics. And so, John, I know how busy you are. Again, thank you so much for your time. I do want to hand it to you, though, in case you had any final words, final thoughts, anything that you want to leave myself and also our audience with.
Well, I'm very grateful to God for giving me this opportunity to work on these things. I consider it a great privilege, and I'm grateful that He is sustaining my life. I came close to dying during COVID, very close to dying, and so He's given me a extension of life to continue, and so I'm excited about the projects I'm working on. Like I said, I'm hoping to model these steam jets soon, working with a student. And so anybody that is inclined to pray for me. I would gladly receive that, welcome that, because this is a spiritual endeavor. And so appreciate your prayers. And I want to give God the glory. It's quite an adventure. It's been quite an adventure these last, 50 some odd years. The things I've discovered, back when I was working at Los Alamos, I was working with some of the top scientists in the world. And, I had a pretty good idea of what motivated them. And, I could reflect on the discoveries that God had allowed me to make in the realm of creation science. And I could compare with the sort of things that my colleagues were striving for and hoping for. And being in creation science, it's just like I compared it with being on a beach covered with diamonds, and you just wander around, decide, do I pick up this one or that one? Great discoveries were everywhere to be simply, picked up off the ground and put in your basket. And whereas my colleagues, they were hoping that perhaps sometime in their whole lifetime, in their whole career, they would make some kind of discovery. And I looked at what I was doing and saying, well, it's a whole different realm. God's allowing me to make all kinds of discoveries, have all kinds of important insights. And so it's really been an exciting journey. And so young people that are considering how to invest their lives, I would encourage them to consider this very high risk type of career of going all in a creation science career. But it's not for everybody. I believe a person has to have the call of God to undertake it. But if you sense God doing that, calling you, then I would say it's an exciting privilege to be involved in this. And again, there are many, many projects that are just languishing, just waiting for somebody to tackle. And so anyway, I appreciate all the interest, and I thank God for his faithfulness to me all these years. And I want to give him the glory. I thank Jesus for his great salvation, for having secured for me a place in heaven, given me his own righteousness, making me qualified to be in heaven. And so it is a wonderful, wonderful thing to be have this kind of privilege of being one who's saved by Jesus, saved by faith, saved by grace. So I'll leave it there.
Amen. Wow. Very powerful. The perfect final words: saved by faith, saved by grace, all because of Jesus. And glory to God. Clearly he had and continues to have more for you, John, in terms of expanding the kingdom, bringing the lost to the Lord, and also strengthening the faith of believers. And so we will be praying for you, John, that is for sure. And I do want to encourage people in the live chat to continue studying, continue researching. If you've enjoyed what you've heard here tonight, which I'm sure you have, since you've stuck with us for almost 4 hours, time has flown by with you. John, it's been a very informative, thought-provoking stream, that is for sure. And so please, everybody, check the description box of this video for links to John's websites where you can help support him, study these topics more. There's Logos Research Associates. There's globalflood.org. And possibly we can help with these research projects in the future, John, including getting those diamonds tested if it is God's will. And so, Dr. Baumgardner, God bless you. Appreciate all the time and work and energy you put into tonight's show. And to those in the audience, thank you so much for tuning in. I appreciate the comments, the feedback, including the objections and challenges offered by our critics. Hopefully we've planted some seeds, and hopefully we've provided you with a good, thought-provoking, edifying show tonight. God bless you all. Standing for Truth is out.